Hello there, and welcome to the Sleepy Cosmic Lens. Tonight we'll be exploring one of the largest and oldest ecosystems on our planet, the very place where life began and where creatures continue to evolve in the darkness. The oceans are one of the most spectacular wonders on Earth, full of vibrant life and undiscovered mysteries. This journey moves beyond the familiar and into the vast world below, into deep waters where light slowly disappears and the environment changes completely. Where pressure reshapes bodies, where animals glow, drift, hunt, and survive in ways unlike anything on land, where entire ecosystems exist without sunlight, powered by heat and chemistry rising from the planet itself. There are towering underwater mountains, endless plains, deep trenches, and silent migrations that happen every night on a global scale. Much of this world has never been seen directly, yet it plays a role in shaping life across the entire planet. What follows is an exploration of that hidden ocean, the strange creatures that live there, the forces that shape it, and the reasons it remains one of Earth's greatest unknowns. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, just breathe. Let your eyes grow heavy, and let the deep sea cradle your thoughts. Let's begin. The ocean covers more than 70% of Earth. When you look at Earth from space, it isn't green or brown, it's blue. Over 70% of our planet is covered by ocean, stretching unbroken for thousands of miles in every direction. The Pacific alone is so large it could hold all the continents combined. This immense body of water shapes everything about life on Earth. The climate, the air we breathe, even the rhythm of our days and nights through the tides. It absorbs heat from the sun, moves it around the globe, and creates weather patterns that ripple across continents. And yet, when we stand on the shore, it feels like a horizon, a boundary, the edge of the world. But the truth is, it's the ocean that defines our planet. Earth isn't just a rocky sphere in space, it's a water world. We have explored less than 5% of it. Despite all our satellites, submarines, and scientific advances, we've seen only a fraction of what lies beneath the surface. Less than 5% of the ocean has been explored, which means 95% of it is still a mystery. We know more about the surface of the Moon and Mars than we do about the deep sea. Vast mountain ranges, endless plains, and hidden trenches stretch for thousands of miles unseen. Entire species live and die in darkness, never yet glimpsed by human eyes. Each expedition reveals creatures so strange they seem like science fiction: transparent jellyfish, glowing predators, and fish with anatomy unlike anything on land. The ocean is not just unexplored, it's almost entirely unknown. And that means every dive is like stepping onto an undiscovered planet with secrets waiting in the dark. We've mapped more of Mars than our own ocean floor. It may sound unbelievable, but we know more about the surface of another planet than we do about the seafloor beneath our own. Thanks to orbiters and satellites, over 99% of Mars has been mapped in high resolution, the ocean floor only about a quarter. Much of it remains an indistinct blur, inferred from satellite gravity readings or sonar echoes. We've explored the deep with robots and submarines, but the scale is staggering. Earth's oceans cover over 70% of the surface, and their depths are difficult and expensive to reach. As a result, there are canyons, mountains, and entire ecosystems we've never seen. New species are discovered every time we look. In a way, the deep ocean is our last true frontier, an alien world at the bottom of our own, and it lies just beneath our feet, quietly waiting to be understood. In the deep, pressure can crush a submarine like a can. As you descend into the deep ocean, pressure increases fast and dramatically. Every 10 meters down adds another full atmosphere of pressure, the equivalent of the weight of the entire sky. By the time you reach just a kilometer deep, the pressure is 100 times what we feel at sea level. Go farther and it becomes thousands of times greater. At the deepest trenches, the force is more than 8 tons per square inch, enough to crush steel, collapse submarines, and turn hollow objects into twisted wreckage. But astonishingly, life survives, even thrives under these extremes. Creatures down here are soft-bodied, boneless, and uniquely adapted. Their biology is shaped by compression, their movements slow and ghost-like. For us, this realm is lethal. For them, it's home. The crushing weight of the deep is one of its defining features, and one of its greatest mysteries. The ocean's deepest point could swallow Everest with room to spare. The Mariana Trench in the western Pacific Ocean holds the record for the deepest point on Earth. At its lowest measured spot, the Challenger Deep, the ocean plunges to nearly 11,000 meters. If you placed Mount Everest inside it, the peak would still lie more than 2 kilometers below the surface. This trench is not just deep, it's profoundly alien. Temperatures hover near freezing, the pressure is extreme, and yet even here, life persists. Microbes thrive in the mud, arthropods and strange fish flit through the dark, and we've only just begun to explore it. Fewer people have visited the Challenger Deep than have walked on the moon. Each descent requires precision engineering and nerves of steel, but with each journey, we learn more about the limits of life, the shape of the planet, and what waits at the bottom of the world. Life flourishes there without a single ray of sunlight. Sunlight is the engine of life on land and in the ocean's upper layers. But in the deep, light never comes, and yet astonishingly, life continues without photosynthesis. Instead, deep-sea ecosystems run on chemosynthesis, a process where bacteria feed on chemicals like hydrogen sulfide, which bubble up from hydrothermal vents. These bacteria become the base of the food web, nourishing creatures that have never seen the sky. Some animals, like giant tube worms, don't even have mouths or digestive systems. Instead, they host bacteria inside their bodies and absorb energy directly from them. This partnership between microbe and host allows entire ecosystems to bloom in the dark. These strange sunless communities have reshaped our understanding of biology and the possible conditions for life beyond Earth. If life can exist here, it might exist in the deep oceans of other worlds too. The ocean soundscapes are as complex as forests. When we think of the ocean, we often imagine silence, but to a hydrophone, an underwater microphone, the sea is alive with sound. Whales sing in deep, haunting tones that travel across entire oceans. Dolphins click and whistle, shrimp snap their claws like underwater fireworks, and fish croak, grunt, or drum on their own bodies. Together, these voices create soundscapes as rich and layered as the calls of birds in a rainforest. The ocean is never truly silent. Sound travels farther and faster in water than in air, making it the primary language of the sea. For creatures living in darkness, sound is sight, communication, and connection all at once. To drift in these soundscapes is to hear the ocean breathing, humming, and whispering with life, a chorus that has been singing for millions of years beneath the waves we barely know. Entire continents drift on plates beneath the sea. The ocean is not just a surface of water, it is the skin of a living, shifting planet. Beneath it lie tectonic plates, enormous slabs of rock that move slowly over Earth's mantle. These plates carry entire continents with them, drifting a few inches each year. Over millions of years, they break apart, collide, and reshape the face of the Earth. Oceans open and close like slow breaths, and mountains rise from the sea. The Atlantic Ocean, for example, is still widening today as the plates on either side move apart. This drifting explains why fossils of the same species can be found on continents now separated by thousands of miles of ocean. To imagine continents floating on vast plates of stone is to see Earth as alive, always changing. The ocean is not just a boundary between lands, but the stage where worlds are formed. The ocean still holds mysteries we cannot yet imagine. For all our ships, satellites, and submarines, most of the ocean remains unexplored. More than 95% of it is still a mystery, a realm of darkness and pressure, where unknown creatures may drift unseen. Each expedition brings discoveries, new species, new landscapes, even new chemical processes. Yet the vast majority of the deep remains untouched by human eyes. Scientists believe we may have seen less of the seafloor than of the surfaces of Mars or the Moon. Somewhere in the abyss, there may be creatures with forms we cannot picture, ecosystems unlike anything we know. The ocean is a reminder that our planet still holds secrets, that mystery is not confined to distant galaxies. To close your eyes and imagine the unknown depths is to feel wonder and to dream of what might still be waiting in the silent dark. The sea is both our origin and our future. Every life on Earth traces its beginnings back to the sea. Billions of years ago, the first living cells floated in its waters, nourished by the chemistry of the deep. From those tiny sparks, all plants, animals, and humans eventually arose. Even now, the ocean sustains us, giving us food, oxygen, and a stable climate. And as we look toward the future, the ocean may again hold the key to our survival. Its currents regulate the planet's temperature, its ecosystems support our fisheries, and its depths may one day reveal medicines, energy sources, or even clues to life on other worlds. To stand on the shore is to stand at the edge of both our past and our destiny. The ocean is not just where life began, it is where life continues, and where humanity's future may ultimately return. Other creatures are nearly invisible, and that's on purpose. In a place with no shelter, no rocks or coral to hide behind, the best defense is to vanish completely. Many deep-sea creatures have evolved bodies that are almost perfectly transparent. Their skin, muscles, and even some internal organs are made of jelly-like material that barely bends or reflects light. The result is a near-invisible body that predators can't easily detect. Some fish are so transparent you can see their skeletons. Others, like the glass squid, are nearly invisible except for their eyes, which they disguise using mirrors or special pigments. Even their blood lacks pigment to reduce visibility. In the deep ocean, visibility isn't just about hiding from predators. It's about survival at every level. To float unseen through a world without shadows is a powerful adaptation. In the quiet dark, transparency becomes a form of armor, elegant, ghostly, and nearly perfect. The gulper eel can open its mouth wider than its own body. The gulper eel is one of the deep sea's most surreal residents, a shadowy creature with a whip-like tail and a ballooning jaw. Its mouth is so massive it can open wider than the eel's entire body, forming a kind of living fishing net. Despite its fearsome appearance, the gulper eel is not a fast hunter. Instead, it drifts through the blackness, waiting for small fish or shrimp to swim by. Then, with one sudden motion, it opens its enormous mouth and gulps. Its body can stretch to hold surprisingly large meals, making it a master of rare opportunities in a world where food is scarce. It also has a bioluminescent lure at the tip of its tail, a glowing dot that it can wave to attract prey. In the still black waters of the abyss, the gulper eel is part monster, part illusion, and entirely real. Every night, deep creatures rise toward the moonlight. When the sun sets and the ocean surface grows dark, something extraordinary happens in the deep. Millions of creatures, fish, squid, jellyfish, and plankton begin to rise. Slowly, silently, they migrate upward from the twilight zone to feed in the nutrient-rich upper layers. It's called the diel vertical migration, and it's the largest movement of animals on Earth. This nightly journey happens across the globe, from the tropics to the poles, and repeats every 24 hours like a planetary heartbeat. The creatures rise to feed under cover of darkness, then retreat again before dawn to avoid predators. It's a delicate dance between hunger and safety, light and shadow. Most of it is invisible to us, hidden beneath waves and moonlight. But this migration shapes ecosystems, affects carbon cycles, and keeps the deep connected to the surface. In the ocean's rhythm, night is the time to rise. This nightly migration is the largest on the planet. Each evening, trillions of marine animals ascend from the deep, not just a few meters, but sometimes up to a kilometer or more. The sheer scale is staggering. Imagine every living human being rising and falling in perfect synchrony every night. Now multiply that by 1,000. This vertical migration moves more biomass, more total living matter than any other daily movement on Earth. It helps regulate the planet's climate by transferring carbon from the surface into the deep ocean, where it can remain for centuries. And it does all this in near total silence, far from human eyes. Creatures like lanternfish, hatchetfish, and tiny crustaceans make this trek under the cover of darkness, guided by cues we barely understand. Perhaps temperature shifts or the faint rise of moonlight. It's one of the most important processes on the planet, and we're only beginning to understand how it works. Starfish can regrow entire arms. In the tide pools and shallow seas, starfish crawl slowly across the rocks, their arms stretching like rays of the sun. These creatures possess a remarkable ability. If they lose an arm, they can regrow it completely. In some cases, a single arm can even regenerate into a whole new starfish, given enough time. This power comes from their incredible ability to regenerate cells, rebuilding not only muscle and skin, but also their internal structures. For starfish, this isn't just a trick, it's a survival strategy. When attacked by predators, they can sacrifice a limb and later grow it back. Watching a starfish move with calm determination, you might never guess the quiet resilience hidden in its body. Their ability to heal and renew themselves is a gentle reminder of nature's patience and of the hidden powers life can carry within. Some octopuses carry coconut shells as tools. The octopus is known for its intelligence, but perhaps one of its most charming traits is its resourcefulness. In the waters of Indonesia, scientists have observed octopuses carrying coconut shells across the seafloor. They use their arms to tuck the shells underneath their bodies, shuffling along awkwardly while transporting them. When threatened, they assemble the shells into makeshift shelters, hiding inside their portable armor. This is one of the clearest examples of tool use in the ocean, a creature not just reacting to its environment, but actively shaping it to its advantage. The sight is strangely endearing, like watching a traveler carry a suitcase. In the dark and shifting world of the sea, where danger can come from any direction, the coconut octopus has learned to bring safety with it, a reminder that intelligence takes many forms. Even in the silent deep, they can solve puzzles and escape from tanks. Octopuses are masters of problem solving. In aquariums around the world, keepers tell stories of octopuses that unscrew jar lids, lift latches, and even sneak out of their tanks at night. Some have been found wandering the floor, exploring pipes, or slipping into neighboring enclosures to steal food. Their arms are lined with hundreds of suckers, each capable of tasting and touching independently, like having 8 curious hands. But it's not just dexterity. Octopuses seem to think. They learn from experience, remember solutions, and adapt to new challenges. Watching an octopus carefully unscrew a jar to reach a crab inside feels almost human. A glimpse into a mind both alien and familiar. In the silent waters of their tanks, they remind us that intelligence is not ours alone. It is a thread woven through the ocean in forms we are only beginning to understand. An octopus has 3 hearts and blue blood. The octopus is unlike almost any other creature on Earth. Inside its body, not 1 but 3 hearts beat. 2 of them pump blood through the gills, while the third pumps it through the rest of the body. Even stranger, their blood is not red like ours, but blue. This is because it uses copper rather than iron to carry oxygen. Copper works better in the cold, oxygen-poor waters where many octopuses live. When an octopus swims, one of its hearts actually stops beating, only to start again when it rests. These creatures are reminders that life is endlessly inventive, shaping organs and systems to fit the needs of each environment. To imagine blood running blue instead of red, and a rhythm powered by 3 separate hearts, is to glimpse just how many ways life has found to thrive beneath the waves. One strange underwater sound was dubbed the bloop. In 1997, a strange and powerful sound was detected by underwater microphones in the South Pacific. It was low, deep, and loud. So loud, in fact, that it was picked up by sensors over 5,000 kilometers apart. Scientists called it the bloop. At first, it baffled researchers. The sound had characteristics similar to those of an animal call, but no known creature could produce a sound so powerful. Was it a whale? A seismic event? Something unknown? Speculation ranged from deep-sea monsters to undiscovered leviathans. Eventually, the best theory pointed to the cracking and collapse of massive Antarctic icebergs. But for years, the bloop captured the imagination of oceanographers and science enthusiasts alike. It reminded us that the ocean can still surprise us, that sometimes a single unexplained sound can echo through both water and wonder, stirring the imagination as much as the ear. Some fish communicate by drumming on their own bodies. While whales sing and dolphins click, some fish have evolved much stranger ways to communicate. They drum, using special muscles attached to their swim bladders, the internal sacs that help control buoyancy. These fish can create rhythmic thumps, pulses, or grunts. It's a bit like beating a drum from the inside out. These sounds can serve many purposes, attracting mates, defending territory, or signaling distress. The toadfish, for example, makes a humming call so loud it can be heard through the hulls of boats. Other fish use short bursts to coordinate with the group or ward off intruders. In the dark, noisy world of the ocean, sound becomes a private language, one that's often overlooked by human observers. These simple drumming rhythms are reminders that even the quietest fish may have a voice if only we know how to listen for it. Whales dive for miles to sing where no light reaches. Among the deepest divers in the animal kingdom are whales, especially species like the sperm whale and the Cuvier's beaked whale, which can dive over 3 kilometers beneath the surface. They go there to hunt, to hide, and in some cases to sing. Whale song is one of the most haunting and beautiful sounds in nature, long echoing calls that can travel for thousands of kilometers. Some whales dive deep before they begin singing, where ambient noise is lower and the sound can carry farther. These songs may serve many functions, attracting mates, locating others, or mapping the sea using echoes. They're so complex that they may even contain dialects or patterns that change over time. In the dark silence of the abyss, a single whale's voice can fill the water like music in a cathedral. It is sound without light, language without land. Giant squid were once sea monsters until we filmed them alive. For centuries, giant squid were the stuff of sailors' nightmares, glimpsed in fragments, washed ashore in pieces, or tangled in fishing nets. They were called kraken, leviathans, monsters of the deep. No one had seen one alive in its natural habitat until 2012, when Japanese researchers captured the first video of a living giant squid filmed over 600 meters below the surface. What they saw was dazzling, a sleek, graceful creature with shimmering skin and eyes the size of basketballs. Its arms moved like ribboned silk, trailing hundreds of tiny suction cups. It wasn't a monster, it was a mystery made real. The deep sea still holds many secrets, but the giant squid is no longer just a legend. We've seen it, and that glimpse confirmed what mariners had whispered for centuries, that something enormous waits in the dark. Reef-building corals are under threat from warming seas. As beautiful as coral reefs are, they are also fragile. Corals live in partnership with tiny algae that provide them with food and brilliant colour. But when ocean temperatures rise even slightly, the corals become stressed and expel their algae. Without their partners, they turn ghostly white, a process called coral bleaching. If the heat continues, the corals starve and die, leaving behind barren skeletons. In recent decades, warming seas have caused mass bleaching events across the globe, threatening reefs that have stood for thousands of years. Yet there is hope. Some corals are more resilient, capable of withstanding higher temperatures, and scientists are working to protect and restore reef ecosystems. The fragility of corals reminds us that the ocean, for all its power, is also delicate, a living system that depends on balance, and one we are called to care for. Entire atolls are built on ancient volcanic foundations. Scattered across the Pacific are rings of islands that look like necklaces floating on the sea. These are atolls, circular chains of coral that enclose tranquil lagoons. Atolls are born from volcanoes. Long ago, volcanic islands rose from the sea, and corals began to grow around their edges. As the volcano slowly sank beneath the waves, the corals continued to build upward, keeping pace with the rising water. Over millions of years, the volcanic island disappeared beneath the surface, leaving behind a near ring of coral. The result is a natural wonder, an atoll with calm waters at its heart and the open ocean beyond. To walk across an atoll is to stand on the memory of a volcano, transformed into a paradise of sand, palms, and coral. They are reminders that even destruction can create beauty, reshaping the world in unexpected ways. Seagrass meadows produce more oxygen than forests. Beneath the waves, vast meadows of seagrass sway with the current. These underwater plants may seem unremarkable compared to coral reefs or kelp forests, but they are quiet giants in Earth's story. Seagrasses photosynthesize, drawing in carbon dioxide and releasing oxygen. In fact, per square meter, they can produce more oxygen than tropical rainforests. These meadows also act as nurseries, sheltering young fish, seahorses, and turtles among their waving blades. Their roots stabilize the sandy seabed, protecting coastlines from erosion, and they store huge amounts of carbon, locking it away in the sediment for centuries. Yet seagrass meadows are disappearing worldwide due to pollution and coastal development. Protecting them means protecting one of Earth's most important life support systems. To drift above a seagrass meadow is to float over a hidden forest, alive with movement, feeding the air we breathe and keeping our planet in balance. Mangroves protect coastlines from storms. Along tropical shores, mangrove forests stand with their roots tangled like intricate sculptures, half in the water and half on land. These remarkable trees are natural guardians of the coast. Their roots act like living barriers, absorbing the force of waves and storm surges, protecting inland communities from flooding and erosion. At the same time, they provide shelter for fish, crabs, and birds, forming rich ecosystems in the shallow water. Mangroves are also powerful carbon sinks, capturing and storing carbon dioxide in their soil and roots. Yet, like coral reefs, they are under threat from development and climate change. To walk among mangroves is to feel the meeting of land and sea, where trees grow in salt water and roots cradle entire ecosystems. They are protectors and providers, reminders that nature has its own defenses, and that the ocean's edge is alive with resilience. Rivers and lakes exist at the bottom of the sea. It sounds impossible, but it's true. Under the sea, there are rivers and lakes, bodies of water within water. These strange features form when dense, salty brine gathers in depressions on the seafloor. Because the brine is heavier than the surrounding seawater, it doesn't mix easily. Instead, it forms shimmering, slow-moving pools with visible shorelines, currents, and even waterfalls. Some are surrounded by mussels and tube worms, others are eerily still with toxic chemistry that few organisms can survive. Divers and submarines that approach often report a surreal sight, the sensation of flying over a separate sea. These lakes can be tens of meters deep and hundreds wide, complete with waves and ripples. It's a layered world within a world, like a secret ocean hiding inside another. In the deepest reaches of Earth, water doesn't always behave the way we expect. Some undersea pools are so salty, they're toxic. At certain depth, the ocean hides something astonishing. Brine pools, where salt concentrations are so high that the water becomes heavier than the sea around it. These pools can be several times saltier than normal seawater, forming dense lakes on the seafloor that don't mix with the ocean above. The chemistry inside is often lethal to most marine life, lacking oxygen, laced with hydrogen sulfide, and nearly still. Some creatures have adapted to live at the pool's edges, but any fish that wanders too far inside may never come out. Submersibles that explore these pools describe eerie underwater shorelines, complete with rippling surfaces and even waterfalls. The sight of a lake beneath the sea, complete with its own tides and shores, is one of the most surreal discoveries in oceanography. These toxic pools are quiet reminders that the deep doesn't always follow the rules of water. The seafloor isn't flat, it's full of sunken valleys and towering cliffs. When we imagine the bottom of the ocean, it's easy to picture a vast featureless plain, but in reality, the seafloor is just as rugged and dramatic as any mountain range on land, and sometimes even more so. Deep beneath the waves lie steep escarpments, massive undersea cliffs, sprawling trenches, and volcanic ridges. Some cliffs drop for kilometers in near vertical walls, shaped by shifting tectonic plates or ancient landslides. Others form the boundaries of underwater plateaus and fracture zones. Because of the difficulty of mapping the deep, many of these features remained hidden for decades, and some are still being discovered. Just like the continents, the ocean floor is scarred and sculpted by geological time. Every valley is a record of collapse or creation, every ridge a frozen moment of fire. Even where no sunlight ever reaches, the Earth's forces are still at work. Abyssal plains stretch across the ocean like endless deserts. Far below the surface, between 3 and 6 kilometers deep, lie the abyssal plains, vast flat expanses that cover more than half of the ocean floor. These plains are some of the flattest regions on Earth, formed by the slow settling of sediments over millions of years. But while they may seem barren, they are not lifeless. Tiny organisms burrow in the mud, scavengers patrol the darkness, and occasional whalefalls create oases of life. To visit an abyssal plain is to enter a place where time moves slowly, where silence is absolute, and where each particle of marine snow, organic matter drifting down from above, is a treasure. These plains are both alien and familiar, wide, still, and strangely peaceful. They're the true seabed of the world, stretching beyond the limits of light or sight. They are the ocean's quiet, unmoving heart. Some islands disappear beneath the waves again. Just as the ocean can create islands, it can also take them away. Many small volcanic islands born in spectacular eruptions vanish within years as waves and storms erode their fragile rock. In the Pacific, new islands have appeared and disappeared in the span of a single human lifetime, leaving only faint outlines on nautical charts. Rising sea levels add to this process, slowly submerging low-lying atolls and coral islands. Entire communities in places like the Maldives and Kiribati live with the knowledge that their homes may one day slip beneath the waves. The ocean is both giver and taker, sculpting the land as it pleases. An island may rise like a miracle only to vanish again, reminding us that nothing on Earth is permanent. Land and sea are in constant negotiation, and the ocean always has the final word. Coral reefs are built by tiny animals. When you see a coral reef, it may look like colourful stone, a solid wall of rock covered in fish and plants, but reefs are actually alive, built by billions of tiny creatures called coral polyps. Each polyp is a small animal related to jellyfish, with soft bodies that secrete limestone skeletons. Over time, these skeletons accumulate, stacking into massive structures that can stretch for hundreds of miles. The reef becomes a living city, growing slowly over centuries, as each new generation of polyp builds upon the last. The colours we see come from the algae that live inside the corals, giving them food through photosynthesis. Reefs are not just beautiful, they are vital, providing shelter and nurseries for countless marine species. To swim among coral is to wander through an ancient living cathedral, built one tiny creature at a time across centuries of patience. They support a quarter of all marine species. Though coral reefs cover less than 1% of the ocean floor, they are home to about a quarter of all marine life. Fish of every colour dart between the branches, sea turtles glide gracefully overhead, and tiny creatures build their homes among the coral. This astonishing density of life has earned reefs the nickname rainforests of the sea. For humans, they are equally important. Reefs provide food, protect coastlines from waves, and support millions of people who depend on them for fishing and tourism. Yet they are fragile, threatened by warming waters and pollution. When corals die, entire ecosystems can collapse, leaving silence where once there was life. To imagine a reef is to imagine abundance, a kaleidoscope of colours, shapes and movements, all woven together into a single living system. They remind us how rich and interconnected life in the ocean can be. Some corals glow under ultraviolet light. When corals are bathed in ultraviolet light, something magical happens. Their surfaces shimmer with neon colours, glowing greens, blues and reds, that look almost otherworldly. This glow comes from special proteins within the coral that absorb UV radiation and re-emit it as visible light. Scientists believe this bioluminescence may help protect corals from harmful sunlight, or perhaps attract the tiny algae that live inside them. To divers exploring reefs under special lights, it feels like stepping into a dream where the ocean floor shines like a field of stars. These glowing corals are not just beautiful, they hold secrets that may one day help humans develop new medicines and technologies. In their light, we see both the creativity of nature and the endless curiosity it inspires, reminding us that even the smallest creatures can shine with cosmic brilliance. Others feed on nothing but falling dust. Many deep-sea creatures don't hunt, chase, or bite. Instead, they wait. They feed not on other animals but on tiny particles drifting down from the upper ocean. A slow, steady rain of organic matter known as marine snow. These particles are the remains of dead plankton, tiny fecal pellets, discarded exoskeletons, and other microscopic debris. Though each flake is nearly weightless, together they form the primary food source for vast regions of the seafloor. Sea cucumbers, brittle stars, crabs, and deep-dwelling worms sift through this sediment like scavengers in a cosmic snowfall. In some regions, entire ecosystems are sustained by this delicate stream of nutrients. Life here moves slowly, conserving energy, making the most of every particle. In the deep, there are no fast meals, only patience, and the knowledge that even the smallest speck can be a feast. Marine snow drifts down like an eternal ghostly blizzard. Imagine a snowfall that never melts, not of ice but of organic dust. In the deep sea, marine snow is a constant slow-motion blizzard. Tiny flakes of dead plankton, algae, fish scales, mucus, and microscopic waste drift endlessly downward from the sunlit surface. Most flakes are barely visible, some clump together, forming delicate webs or pellets. They can take weeks or even months to reach the bottom. But for deep-sea creatures, marine snow is life. It delivers nutrients to places where nothing grows, linking the surface world to the abyss in a kind of invisible food chain. Some animals filter it from the water as it falls, others graze the seafloor, collecting what settles there. It may seem unremarkable, but this soft, silty snowfall is one of the most important biological processes on Earth, connecting life across layers of depth and time. A whale fall feeds life for decades in the deep. When a whale dies and its body sinks to the bottom of the ocean, something extraordinary happens. That carcass, sometimes weighing over 30 tons, becomes a vast temporary ecosystem known as a whale fall. For decades, layer by layer, life moves in. First come scavengers, sharks, hagfish, and giant amphipods that strip away the flesh. Then other creatures move in to feast on scraps and soft tissue. As time passes, the bones themselves become food. Bacteria that feed on fats within the bones release chemicals like hydrogen sulfide, attracting chemosynthetic worms and mollusks, the same kinds of life seen at hydrothermal vents. A single whale fall can support over 100 species of animals, many of which are found nowhere else. In the dark, where food is rare, a whale's body becomes a gift, a slow-burning feast that echoes through the ecosystem for years. Some creatures eat bones and nothing else. Deep in the ocean, where meat is scarce and survival is hard, a few creatures have evolved to do the unthinkable. They eat bones. The most famous of these is the Osedax worm, also known as the bone-eating zombie worm. It has no mouth, no stomach, and no eyes. Instead, it drills into the bones of fallen whales using acid, then absorbs the nutrients inside. To do this, it relies on symbiotic bacteria that help it digest fats and collagen. These worms grow root-like tendrils that anchor into the bone, while feathery plumes extend from their bodies to extract oxygen from the water. They are delicate, ghostly, and oddly beautiful, a perfect example of life adapted to extremes. In a world where food arrives once in a generation, nothing is wasted. Even bones become a banquet, even decay becomes life. The Southern Ocean encircles Antarctica with endless winds. At the bottom of the world lies a restless ocean, unlike any other. The Southern Ocean circles Antarctica completely unbroken by continents. Because of this, its currents can race all the way around the globe, creating the strongest continuous flow of water on Earth. These currents connect the Atlantic, Pacific, and Indian Oceans, mixing their waters and regulating Earth's climate. The winds above the Southern Ocean are equally powerful, whipping the seas into towering waves that crash against the icy continent. Despite the harshness, life thrives here. From vast colonies of penguins to pods of orcas and humpback whales, the Southern Ocean is a reminder that even at the planet's edge, where cold and wind seem unrelenting, the sea remains alive, circling endlessly. It is like a girdle of water and air, binding Earth's oceans into a single living system that never stops moving. The Arctic Ocean is covered by shifting ice. The smallest of Earth's oceans, the Arctic, is capped by a vast sheet of floating sea ice. This frozen lid is never still. It cracks, drifts, and reforms with the seasons, creating a shifting, ever-changing landscape. In summer, the ice retreats, opening passages of water and exposing hidden ecosystems beneath. In winter, it expands again, stretching into a frozen desert. Beneath the ice, life carries on in quiet resilience. Plankton bloom in the sunlight, filtering through the ice. Fish glide below, and seals hunt in the cold, silent dark. Polar bears wander across the frozen surface, depending on the ice to hunt. As the climate warms, the Arctic Ocean is changing faster than almost any other place on Earth. The melting ice is a reminder that this frozen sea is not eternal. It is fragile, shifting, and deeply connected to our world's future. The ocean's surface hides mountain peaks taller than the Alps. The ocean may look flat and endless from above, but beneath its surface lie mountains taller than the Alps. Seamounts, underwater mountains formed by volcanic activity, rise thousands of feet from the seafloor. Many never reach the surface, their peaks hidden just below the waves. Some are higher than Mount Rainier, yet completely invisible from land. These seamounts create unique ecosystems as currents swirl around them, bringing nutrients that attract fish, corals, and whales. Entire communities form in these hidden places, thriving in the shadow of underwater peaks. To think that such towering mountains exist, unseen beneath the waves, is humbling. They remind us that most of Earth's wonders remain hidden from sight. The next time you gaze at the horizon, remember, just below that calm surface, peaks taller than alpine summits rise silently through the deep, unseen and unknown. Some trenches are so deep they could swallow Mount Everest. The ocean is home to immense chasms that make even the greatest mountain seem small. The Mariana Trench, the deepest known, plunges nearly 7 miles beneath the surface. If Mount Everest were placed inside, its peak would still be submerged by more than a mile of water. These trenches are formed where tectonic plates collide, forcing one beneath the other into the Earth's mantle. They are some of the most extreme environments on the planet, dark, cold, and under crushing pressure. Yet, even here, life exists. Strange organisms cling to the rocks, feeding on nutrients that drift down from above or emerge from deep within the earth. These trenches are not just scars on the seafloor, but doorways into the unknown. To imagine their depth is to imagine standing at the base of Everest and still looking up through miles of dark water. Cold and darkness slow down time for living things. Life in the deep ocean moves at a different pace. Temperatures often hover just above freezing, and light never penetrates past a certain depth. These conditions change everything, especially time. Cold temperatures slow metabolic rates, allowing animals to conserve energy and reduce wear on their cells. Many deep-sea creatures grow slowly, reproduce rarely, and live for decades or even centuries. A single meal might last for weeks. A generation might stretch across half a century. In the absence of light and warmth, evolution favors stillness, patience, and endurance. What feels like a moment on the surface might be a year in the deep. This slowness is not a weakness, it's a strategy. In a world where food is rare and change is gradual, living slowly means living well. In the deep, time flows like the cold water, vast, gentle, and unhurried. Some fish survive by producing their own antifreeze. In the coldest parts of the ocean, where temperatures dip below freezing, many fish would freeze solid without special adaptations. But some have evolved a clever solution: antifreeze proteins. These proteins circulate in their blood and tissues, binding to ice crystals and preventing them from growing. It's the same basic principle as the antifreeze in a car, but far more elegant. These antifreeze-producing fish are found in polar oceans and deep frigid waters. Their bodies remain soft and flexible even in the cold, allowing them to move, feed, and survive in environments that would otherwise be fatal. Scientists have even studied these proteins to improve cryopreservation techniques on land. It's a reminder that extreme cold isn't always a barrier. In nature, it's a challenge, and evolution loves a challenge. Where ice would stop most hearts, these fish keep swimming. Others are so soft they'd collapse if brought to the surface. Some deep-sea creatures are made almost entirely of gelatinous material, soft, delicate, and nearly formless. At great depths, this softness is an advantage. Without a rigid skeleton, they can resist the crushing pressure simply by being flexible. But if they were suddenly brought to the surface, they'd collapse. Not from injury, but because their bodies depend on high pressure to maintain shape. The famous blobfish, for example, looks like a saggy cartoon on land, but at its natural depth, it's sleek and well-formed. Other creatures like certain jellies or comb jellies would disintegrate almost instantly in normal air pressure. These animals have evolved for one specific environment, the deep. Their beauty is fragile, their survival is precise, and their bodies are shaped by forces most of us will never feel. The invisible weight of miles of water pressing in from all sides. Some deep creatures have no bones at all. In the crushing pressure of the deep ocean, softness becomes a form of strength. Many creatures here have no bones, no rigid skeletons or hard shells. Instead, they're made of soft tissues, cartilage or gelatinous material that can bend and flex with the water around them. This makes them incredibly pressure tolerant. While a bony body might crack or collapse, these creatures simply compress and expand as needed. Some look like drifting ghosts. Others resemble ribbons, umbrellas, or glass sculptures. Their softness isn't a flaw, it's an exquisite adaptation. Even fish that do have skeletons often have lightweight, flexible bones, or reduced structures that give them more mobility and less fragility. In the deep, structure is secondary. Survival means yielding to the environment, moving with the currents, and staying quiet in the dark. These soft-bodied wonders remind us that vulnerability can also be resilience. Entire ecosystems exist with no sunlight ever. Most of life on Earth depends on sunlight. Plants capture it, animals eat the plants, and the cycle continues. But deep in the ocean, far beyond the reach of even the faintest ray, entire ecosystems exist in complete and permanent darkness. These aren't just a few stray species. Around hydrothermal vents and cold seeps, scientists have found dense communities of life: tube worms, shrimp, crabs, mussels, and strange fish. There are no photosynthetic plants, only organisms that live by chemosynthesis, using chemical energy instead of light. These ecosystems don't depend on the surface at all. They form their own closed worlds powered by the heat and elements leaking from inside the Earth. When these environments were first discovered in the 1970s, they upended our understanding of what life needs, and they offered a possibility even more profound, that life might not need sunlight at all. Instead of photosynthesis, life down there runs on chemistry. Sunlight fuels almost every food chain on the planet, except in the deep ocean. Here, something remarkable happens. Life runs on chemistry. Around hydrothermal vents and methane seeps, microbes use the energy stored in chemicals like hydrogen sulfide, methane, and iron to create organic matter. This process, called chemosynthesis, allows life to flourish without the sun. It's similar to photosynthesis, but instead of light, it uses molecules from the Earth itself. These chemosynthetic microbes form the base of entire ecosystems, feeding tube worms, clams, and crustaceans that gather in dense colonies around vents. It's a different kind of energy, ancient, elemental, and invisible, and it may be one of the earliest forms of life on Earth. Some scientists even believe chemosynthesis could support life on other planets or moons. In the deep sea, chemistry becomes cuisine, and life rewrites the rules of survival. Microbes feed on sulfur that leaks from Earth's crust. At hydrothermal vents, the water gushing out isn't just hot. It's full of dissolved minerals, including toxic chemicals like hydrogen sulfide. This gas would be deadly to most surface life, but in the deep, certain microbes have evolved to feed on it. These sulfur-loving bacteria form dense mats on rocks, atop vent chimneys, and even live inside the tissues of larger animals. They use the energy from the sulfur to fuel chemosynthesis, creating sugars and organic molecules that support other life. Some tube worms have no mouths or digestive systems at all. Instead, they house these microbes within their bodies and absorb the nutrients they produce. It's a remarkable partnership: sulfur from the earth, microbes from the deep, animals from the dark. Together, they form ecosystems as rich and complex as any coral reef, without ever needing light. These tiny organisms power entire deep-sea food webs. In the deep, where no light penetrates, the smallest creatures often carry the greatest weight. Chemosynthetic microbes, though invisible to the naked eye, form the base of deep-sea food chains around vents and cold seeps. They transform toxic chemicals into energy, producing organic matter that feeds shrimp, crabs, mollusks, and other vent dwellers. These in turn feed larger predators like deep-dwelling fish or octopuses. Every life form in the system ultimately depends on the microbes, even if they never interact directly. It's a web that doesn't begin with sunlight, but with sulfur, methane, and iron. Without these microscopic powerhouses, the vent communities would collapse. Their role is quiet, constant, and vital. And because chemosynthesis might predate photosynthesis, these microbes may represent one of life's oldest strategies, a kind of living memory from the earliest oceans. In their simplicity lies the key to an entire hidden world. Cold water corals build vast cities in the dark. Coral reefs aren't just tropical. In the freezing depths of the ocean, far from sunlight, cold water corals quietly build vast, complex structures that rival their shallow water cousins. These corals don't rely on photosynthesis. Instead, they catch tiny particles of food drifting through the current using delicate feathery arms. Over thousands of years, they grow into massive reefs, some stretching for kilometers. These reefs provide shelter for countless deep-sea species: fish, worms, crustaceans, and sponges. They're hotspots of biodiversity in an otherwise sparse world. Many cold water corals grow slowly, just a few millimeters per year, but given enough time, they can form underwater cities teeming with life. These reefs are hard to reach and only recently mapped by sonar and submersible expeditions. Some have already been damaged by trawling or climate change. But even in the darkness, they continue to grow, delicate fortresses sculpted by time. Some coral reefs are older than human civilization. In the deep ocean, coral grows slowly, sometimes just a few millimeters per year. But given enough time, that slow growth becomes something monumental. Some cold water coral reefs are estimated to be more than 8,000 years old, meaning they began forming before the first cities were built on land. These reefs are hidden in darkness, built by creatures that never see the sun, and yet, over centuries they form towering mounds and sprawling habitats that shelter entire ecosystems. Each new coral polyp builds on the skeletons of those that came before, layer upon layer across millennia. While shallow reefs often come and go with the tides of warming oceans, some deep reefs have endured ice ages and survived the shifting of continents. These aren't just reefs, they're living archives built slowly in silence, telling stories that long predate our own. Deep water corals grow without ever seeing the sun. Unlike the bright corals of tropical shallows, deep water corals have no need for sunlight. They don't rely on algae for food as their surface-dwelling cousins do. Instead, they capture small bits of drifting organic matter from the water around them, tiny particles of marine snow, bits of dead plankton, and microscopic life. These corals grow in cold, dark water, sometimes more than 1,000 meters deep. Their shapes vary wildly: spirals, fans, branches, and curls. Some glow faintly under special lighting, revealing colors hidden from natural view. Though they live far from human eyes, they are vital to deep-sea biodiversity, forming reef structures that act as shelters, nurseries, and hunting grounds. Their beauty is subtle, often seen only through the lens of a remote camera, but it's there, intricate, delicate, and undiminished by darkness. New coral reefs are still being found today. With all our technology, it might seem like we've already discovered most of what Earth has to offer, but in the deep ocean, surprises still wait. In recent years, scientists have discovered entirely new coral reefs, some stretching for kilometers, others hidden beneath submarine cliffs or along continental slopes. One reef off the coast of South Carolina was over 130 kilometers long and previously unknown. These discoveries often happen by accident: a sonar scan, a passing submersible, or a curious blip on a map. The deep is vast and largely unexplored, so it's likely that many reefs and the life they support remain unseen. With each new reef comes new questions. How old is it? What species live there? How can it be protected? Even now, the ocean continues to surprise us, and every new reef is a quiet reminder that Earth still holds secrets. We use robots to explore where no human can swim. The deep ocean is a place of extremes: freezing temperatures, intense pressure, and absolute darkness. It's no place for unprotected humans, so instead we send robots. These machines, called ROVs, remotely operated vehicles, are equipped with cameras, lights, robotic arms, and sensors. Piloted from ships at the surface, they can dive for hours or even days, transmitting real-time video and data from miles below. Some can hover above vents, others collect samples, measure temperature, or map terrain with sonar. They've been used to discover new species, study deep-sea ecosystems, and even locate shipwrecks lost for centuries. The footage they return is often breathtaking: glowing jellies, towering coral, volcanic landscapes. These robots don't just extend our reach, they extend our imagination in a world we cannot visit ourselves. They go in our place, eyes in the dark, explorers of the unseen. Some drones dive for hours, beaming back glimpses of the unknown. Many of today's deep-sea drones are autonomous, meaning they don't need constant human control. These AUVs, autonomous underwater vehicles, follow programmed paths, gliding through the ocean in search of data. Some map the seafloor in high resolution, others measure temperature, salinity, or chemical signatures in the water. Equipped with cameras, lights, and sensors, they can drift through the abyss for hours, even days, sending their findings back via satellite when they return. These drones can explore tight spaces, follow currents, and enter regions that would be too risky for human divers or tethered robots. They've found hydrothermal vents, coral gardens, and entire ecosystems we didn't know existed. And with every mission, they teach us something new. In the deep, where even light cannot go, machines carry our curiosity, quietly charting a world we've only just begun to understand. A few submarines can carry humans to the ocean's abyss, while most deep-sea exploration is done by robot. A few specialized submersibles are built to carry human passengers all the way down. These vessels are shaped like reinforced spheres, able to withstand crushing pressures many kilometers below the surface. Inside, explorers sit shoulder to shoulder in cramped darkness, peering through tiny windows or watching live feeds from cameras outside. The experience is quiet, surreal, and otherworldly, a slow descent into cold silence. Only a handful of humans have ever visited the Challenger Deep, the deepest known point in Earth's oceans. Most descents last several hours, with only minutes spent on the seafloor. But what's seen there leaves a lasting mark: alien landscapes, strange creatures, and the inescapable sense of isolation. These manned dives are rare and dangerous, but also deeply human. In a world mostly beyond our reach, sometimes we still choose to go in person. In January 1960, two people reached the deepest part of the ocean. On January 21st, 1960, oceanographer Jacques Piccard and US Navy Lieutenant Don Walsh descended into the Challenger Deep, the deepest known part of the world's oceans. Their vehicle was the Trieste, a deep-diving research bathyscaphe built like a reinforced steel balloon. It took them nearly 5 hours to reach the bottom, over 10,000 miles below the surface. Down there, they found total darkness, crushing pressure, and surprisingly, signs of life. Though their visibility was limited, they reported seeing flatfish and shrimp-like creatures. They stayed on the seafloor for just 20 minutes before beginning the long journey back up. No one had ever gone that deep before, and no one would again for more than 50 years. Their quiet dive into the deepest part of Earth marked a turning point in human exploration, a moment when courage met the unknowable and didn't turn back. Their vessel was called the Trieste, and it survived the crushing dark. The Trieste was unlike any other submarine ever built. Its most important feature was its pressure sphere, a thick steel capsule just large enough to hold 2 people, suspended beneath a massive tank filled with gasoline for buoyancy. At the bottom of the ocean, the pressure exceeds 8 tons per square inch, enough to crush most submarines like paper. But the Trieste held firm. Its descent was slow, its windows tiny, and its interior claustrophobic. The walls groaned. A viewing panel cracked from the pressure, but it didn't fail. When Piccard and Walsh reached the bottom, they stirred up so much sediment that they couldn't see outside, only the faint glow of their lights swallowed by swirling darkness. Still, they had made it. The Trieste proved that humans could go deeper than ever imagined, and for a long time, it remained the only vessel to do so. Fewer people have visited the Challenger Deep than the Moon. As of today, fewer than 20 people have ever visited the Challenger Deep, the deepest known point in Earth's oceans. In contrast, 12 astronauts walked on the Moon during the Apollo missions. The Challenger Deep is more remote, more hostile, and harder to reach than outer space. In many ways, the crushing pressure, total darkness, and extreme isolation make each descent a monumental engineering and psychological challenge. For decades after the Trieste dive, no one returned. Then, in 2012, filmmaker James Cameron completed a solo dive to the bottom, becoming the first person to go alone. In the years since, a handful of other missions have followed, each revealing something new. But still, it remains one of the least visited places on Earth, a pit in the planet so deep, so silent that most of it is still untouched, a kind of underwater lunar surface. Today's explorers use cameras, lights, and robotic arms. Modern deep-sea exploration blends technology and precision. While manned dives still occur, most research today is carried out by remotely operated vehicles, ROV, robotic explorers equipped with high-definition cameras, bright LED lights, and multi-jointed arms that can collect samples, place instruments, or even pick up fragile creatures without harming them. These machines are guided by pilots aboard research vessels on the surface, sending back live video feeds from depths of thousands of meters. Some ROVs are built for mapping, others are designed for science, and all are made to survive the extremes of the deep, pressure, cold, and total darkness. Their lights cut through the black like search beams, revealing coral forests, vent fields, or drifting jellies. And because they can stay down for hours or days, they give us a window into a world we could never see on our own. They are our eyes in the abyss. Every deep dive reveals something new and unexpected. One of the most exciting truths about deep ocean exploration is also the simplest. We always find something new. Every dive, whether by submersible, ROV, or autonomous drone, brings unexpected discoveries. Sometimes it's a strange new fish with fins like wings or jaws like traps. Sometimes it's a colony of deep-sea coral in a place no one thought they could grow. Sometimes it's a sound we can't explain, a chemical anomaly, or an ecosystem built around a volcanic vent we didn't know existed. Even after decades of exploration, the deep ocean continues to surprise us. In fact, scientists estimate that over 90% of deep-sea species remain undiscovered. Every descent is a kind of first contact, not with aliens from space, but with life from our own planet. In the dark, discovery is not rare, it's the rule. Many creatures found in the deep are still unnamed. In the deep ocean, discovery often comes faster than classification. Many of the animals captured on camera by deep-sea drones, or collected during expeditions, don't match anything we've seen before. Some resemble known species, but differ in shape, color, or size. Others are so strange that scientists don't even know where to place them. It can take years, even decades, to study a single specimen, compare its genes, and give it a formal name. In the meantime, researchers give them nicknames: Dumbo octopus, psychedelic jelly, gummy squirrel. These placeholders remind us that we're still early in our understanding. The deep sea is full of creatures that science hasn't yet described, animals that live and die without ever appearing in a textbook or database. For now, they drift unnamed, glowing and feeding in silence, but their stories are waiting to be told. The deep sea is Earth's final living frontier. We've explored mountaintops, deserts, and even the surface of the moon. But the deep sea remains Earth's least known realm. It stretches across more than half the planet's surface, yet most of it has never been seen, not because it's unreachable, but because it's vast, dark, and difficult. It's a place where pressure crushes, light fades, and time slows. But it's also alive, pulsing with creatures that glow, drift, or burrow, many of which are still undiscovered. In this landscape of trenches, vents, and plains, life has adapted in ways we're only beginning to understand. The deep sea is not barren, it's brimming with secrets, some ancient, some utterly new. It is a frontier not of conquest, but of curiosity, a reminder that even here on our own blue planet, wild unknowns still remain. Mapping the ocean floor is one of science's greatest challenges. The surface of Earth's oceans covers more than 300 million square kilometers, yet less than 1/4 of the seafloor has been mapped in high resolution. Why? Because mapping the deep is hard. Satellites can't see through water, and sonar takes time to create detailed maps. Ships must crisscross the ocean slowly, bouncing sound waves off the bottom and measuring the echoes. It's like painting a portrait with a flashlight in the dark, one brushstroke at a time. The deeper the water, the harder it becomes. Trenches, ridges, and valleys can distort readings, equipment must survive harsh conditions, and it's all incredibly expensive. But progress is happening. Projects like Seabed 2030 aim to chart the entire ocean floor within this decade. With every new map, the deep becomes a little less hidden, and the mysteries a little closer to home. Satellites help reveal the hidden landscape of the deep. Even though satellites can't see the seafloor directly, they can help us infer its shape. By measuring tiny variations in the ocean's surface height, caused by underwater mountains and trenches tugging on Earth's gravity field, scientists can build low-resolution maps of the ocean bottom. For example, a seamount creates a slight bulge in the sea surface above it, just a few centimeters high. By stitching together satellite data over time, researchers can detect ridges, valleys, and other features no one has seen. These maps lack detail, but they're an essential first step, guiding sonar surveys, ship expeditions, and robotic dives. In this way, space helps us understand the deep. Satellites orbit hundreds of kilometers above the planet, yet they whisper clues about places 11 kilometers below the waves. Sometimes the tools that look out into space also help us look back into Earth's own depths. The deepest point is deeper than Mount Everest is tall. The deepest point we know of is the Mariana Trench's Challenger Deep. If you dropped Mount Everest into it, the summit would still lie more than a mile underwater. At nearly 7 miles deep, the pressure there is more than 1,000 times greater than at the surface. It is a place of crushing darkness beyond the reach of sunlight, where life persists against unimaginable odds. Few submersibles have ever made the descent, and each time they've returned with images of a silent alien world. The creatures there are adapted in extraordinary ways, bodies soft and flexible to withstand pressure, bioluminescence to signal and lure in the dark. Standing on a mountain peak feels like touching the sky, but descending into Challenger Deep is like touching the unknown, the bottom of our world. Entire mountain ranges lie hidden beneath the waves. Beneath the ocean, the landscape is anything but flat. Entire mountain ranges rise and fall, stretching across the seafloor. The Mid-Atlantic Ridge alone is longer than any chain on land, over 40,000 kilometers of peaks and valleys. Most of it is hidden far below the waves, invisible to us except through sonar maps and occasional glimpses from submersibles. These mountains are alive in their own way, created by the Earth itself as tectonic plates shift and spread. New rock is born here every day, pushing the seafloor apart. In some places, these ridges break the surface, forming islands like Iceland, where fire and ice meet above the waves. To think that we walk across mountains on land, while entire worlds of peaks, cliffs, and ridges remain concealed beneath the sea, is to realize how much more there is left to discover. Some features were found entirely by accident. Not all discoveries in the deep are made by design. In fact, many of the most remarkable underwater features, including coral reefs, seamounts, and hydrothermal vents, have been found completely by accident. A sonar signal might return an unexpected echo, a deep diving robot might catch a glimpse of a strange shape, or a passing research vessel might notice an anomaly on its instruments and decide to investigate. One of the world's largest deep-sea reefs was discovered simply because a team took a detour. These surprises are a reminder of how little we truly know. In the deep, there are no signs or landmarks. Most of the seafloor remains uncharted, so even the most routine expedition might stumble upon something no one has ever seen. The ocean is full of quiet astonishments, waiting not for permission, but for curiosity. Underwater volcanoes lie hidden beneath miles of water. Beneath the ocean's surface, volcanoes are everywhere. In fact, the majority of Earth's volcanic activity happens underwater. Along the mid-ocean ridges, where tectonic plates pull apart, magma rises from deep within the planet, building up new seafloor. These underwater eruptions form massive volcanic chains and seamounts, some of which grow tall enough to become islands, but most remain hidden beneath kilometers of water. Their heat fuels hydrothermal vents, their shape influences ocean currents, and their eruptions can reshape entire landscapes without ever breaking the surface. Some undersea volcanoes are active, others dormant, and many more have yet to be discovered. Because of the difficulty in observing them directly, we often only detect eruptions after the fact through seismic readings, discolorations in the water, or sudden blooms of microbial life. Earth is still forming itself beneath the sea, one quiet eruption at a time. Some can erupt without a single splash. Not all volcanic eruptions are dramatic. In the deep ocean, an eruption can happen in total silence with no explosions or fire, just magma flowing from fissures onto the seafloor. The immense water pressure suppresses steam and gas, muffling the blast. Instead of fountains of lava, these eruptions produce slow, creeping flows that cool rapidly into pillow-shaped rocks. Sometimes these events go completely unnoticed until a submersible stumbles upon the fresh formations, still warm and steaming. In other cases, sensors detect slight temperature changes or seismic tremors, hinting that something has occurred deep below. These quiet eruptions are incredibly common and essential. They build new crust, fuel hydrothermal vent systems, and provide heat and chemicals that support life in the abyss. In the deep, fire doesn't rage, it seeps, and in the darkness, Earth remakes itself without ever disturbing the surface above. Others slowly build giant domes of lava in the abyss. Not all volcanoes explode with fire. Some, deep beneath the sea, ooze lava so slowly that it forms enormous underwater domes, smooth, bulbous mounds called lava pillows, or submarine lava domes. These structures are built layer by layer as molten rock flows from deep fissures in the seafloor, spreads out and quickly cools into rounded shapes under intense water pressure. Some domes span kilometers in diameter and rise hundreds of meters off the ocean floor, taller than skyscrapers, but invisible from above. Because they erupt slowly and silently, they can take decades to build, and they often go undetected until mapped by sonar or spotted by a passing submersible. These lava domes are the quiet architects of the ocean floor, slowly reshaping Earth's surface beneath miles of dark water. They remind us that creation doesn't always arrive with noise. Sometimes it rises in stillness. The seafloor is recycled by the Earth itself. Unlike the continents, which persist for billions of years, the ocean floor is constantly being created, destroyed, and recycled. At mid-ocean ridges, new crust is formed as magma rises and cools. At subduction zones, deep trenches where one tectonic plate slides beneath another, that crust is slowly pulled back into the Earth's mantle, where it melts and begins the cycle again. The entire seafloor is on a kind of conveyor belt, moving outward from ridges and downward at trenches. No part of the ocean bottom is permanent. In fact, the oldest known seafloor is only about 200 million years old, ancient by human standards, but young compared to continental rocks. The Earth continuously reshapes itself beneath the sea, breaking and remaking the planet's crust without pause. It's a process that spans lifetimes, continents and oceans, quietly turning rock into fire and fire into rock again. Ocean plates move and shift like slow-motion tectonic gears. Earth's outer shell is divided into large slabs of rock called tectonic plates, and many of them lie beneath the ocean. These oceanic plates move constantly, though so slowly that we usually don't notice. They slide past one another, collide, or pull apart at speeds of just a few centimeters per year, about as fast as your fingernails grow. But over millions of years, this slow drift reshapes continents, forms islands, creates deep trenches, and builds underwater mountains. When two ocean plates meet, one may be forced beneath the other, triggering earthquakes or volcanic eruptions. When they spread apart, new crust is born. The deep ocean is one of the most active zones of plate movement, a hidden engine that drives much of Earth's surface activity. We walk on solid ground, but beneath us, the planet moves in slow, grinding rhythms. The Atlantic Ocean grows wider by inches every year. The Mid-Atlantic Ridge is a vast underwater mountain range that runs like a seam down the center of the Atlantic Ocean. Along this ridge, two tectonic plates, the North American and Eurasian plates, are slowly pulling apart. As they separate, magma rises from below, creating new seafloor. The result, the Atlantic Ocean is growing, widening by about 2.5 centimeters per year. It's a pace so slow you'd never notice in a lifetime. Yet over millions of years, it adds up to oceans being born, continents drifting, and coastlines changing shape. If this process continues, the Atlantic could eventually become wider than the Pacific. Plate tectonics isn't just something that happens during earthquakes. It's a constant invisible force reshaping our world from the bottom up. The ocean, it turns out, is expanding, one quiet inch at a time. Some of Earth's deepest earthquakes happen far beneath the sea. Most people think of earthquakes as shallow surface events, but some of the most powerful and mysterious quakes occur deep beneath the ocean, where tectonic plates grind, bend, and break under extreme pressure. These deep focus earthquakes can originate hundreds of kilometers below the surface, often in subduction zones where one plate is being forced beneath another. In some cases, these quakes are so deep and distant that they go unnoticed by anyone on land. Others send tremors that rattle entire coastlines. Scientists still don't fully understand how rocks can crack under such pressure. The conditions are extreme and the physics complex, but one thing is clear: beneath the calm surface of the ocean, the planet is restless. The deep doesn't just host strange creatures. It holds tectonic forces as powerful as anything on land, forces that shape the world in silence. Undersea landslides can trigger devastating tsunamis. When massive amounts of sediment suddenly collapse from a continental slope or seamount, the result is an underwater landslide, one that can displace enormous volumes of water and trigger tsunamis. These undersea avalanches are known as submarine landslides, and they can occur after earthquakes, volcanic eruptions, or even as a result of gradual build-up and failure over time. One of the most famous examples, the Storegga slide, occurred off the coast of Norway about 8,000 years ago and sent tsunami waves crashing into nearby lands. These events are rare, but when they happen, they can be catastrophic and difficult to predict. Some landslides involve more material than all the rivers of the world carry in a year. The deep may seem still, but beneath the sea floor, sediments wait under tension, poised to shift, and when they do, the ocean moves with terrifying force. These landslides move more material than any river. When an underwater landslide occurs, it doesn't just stir up sediment, it can move billions of tons of material in a single event. Some submarine landslides are larger than anything we see on land, displacing more volume than all the rivers on Earth combined might carry in a year. The scale is staggering. One massive collapse can sweep mud, sand and rock across hundreds of kilometers of ocean floor. These slides reshape underwater landscapes, destroy communication cables, and sometimes trigger tsunamis that reach distant shores. Because they happen deep below the surface, they're often invisible until their effects are felt or discovered years later through sediment cores and bathymetric scans. It's easy to think of the ocean floor as still and settled, but it isn't. Even in darkness, gravity pulls, pressure builds, and mountains fall. The deep is always in motion, sometimes suddenly, sometimes forever. Vast underwater canyons slice through the continental shelf. Just offshore from many continents, hidden beneath the waves, lie submarine canyons. Massive valleys carved into the seafloor, often stretching from the edge of the continental shelf down into the abyssal plains. These canyons can be hundreds of kilometers long and several kilometers deep, rivaling the largest canyons on land. They're shaped by ancient rivers, landslides, and powerful underwater currents that continue to sculpt them even today. Some are steep and narrow, others are wide and winding. Their walls may host coral, sponges, or filter feeders clinging to the slopes, and their channels act like superhighways for sediment, nutrients, and even marine life. Though hidden from view, these canyons are vital parts of the ocean's circulatory system, pathways that connect the shallow coastlines to the deep sea. To dive into one is to explore a world of silence, depth, and shadow, carved not by time alone but by flow. One canyon under the sea is bigger than the Grand Canyon. Most people know the Grand Canyon as one of the largest natural wonders on land. But beneath the ocean, there's a canyon that's even longer and deeper. The Zimchug Canyon, located in the Bering Sea, this massive underwater gorge plunges more than 2.5 kilometers deep and stretches wider than the Grand Canyon at its widest point. It was carved not by wind or rain, but by powerful currents and gravity-driven flows that have eroded the seafloor over millions of years. Like its terrestrial cousin, Zimchug has steep walls, winding channels, and a complex structure of ridges and slopes. But unlike the Grand Canyon, it lies in complete darkness, barely mapped and rarely visited. The size and scale of such hidden features remind us how much of Earth's grandeur remains unseen. Not because it's far away, but because it's underwater. These submarine valleys funnel sediment to the abyss. Submarine canyons aren't just dramatic, they're dynamic. These deep valleys play a key role in transporting sediment from land to the deep ocean. Storm runoff, river discharge, and coastal erosion all contribute material to the continental shelf, but it's the canyons that funnel it down into the abyss. As the sediment flows, it forms turbidity currents, dense, fast-moving underwater avalanches that can travel for hundreds of kilometers along the canyon floors. These currents carve, deposit, and reshape the seafloor as they go, creating layered sediments in the deep ocean basins. Over time, this process builds up thick blankets of silt and clay that bury the ocean floor and preserve a record of Earth's past. In this way, submarine canyons act like geological arteries, carrying not just earth and stone, but the story of everything that has washed down from the land above. The ocean floor stores the history of Earth's climate layer by layer, year by year. The ocean floor collects a record of the world. Tiny particles of dust, volcanic ash, pollen, and microscopic shells settle to the bottom, slowly forming sediment layers that can be thousands of meters thick. These sediments trap chemical signatures and biological clues that reflect the Earth's past. The temperature of the oceans, the levels of carbon dioxide, the movement of continents, and even the timing of mass extinctions. By drilling cores into the seafloor and analysing the contents, scientists can read this record like pages in a book. Some cores stretch back tens of millions of years, revealing ice ages, warm periods, asteroid impacts, and ancient ecosystems long vanished. In the deep, the past never disappears. It settles softly, accumulates silently, and waits undisturbed until we come looking for the story it has to tell. Ancient sediment cores hold secrets from millions of years ago. A single sediment core from the deep ocean might look like nothing more than a column of mud, but hidden within are clues to Earth's most dramatic changes. Each layer is a timestamp, recording a season, a storm, or an extinction. Cores have revealed traces of the asteroid that ended the age of the dinosaurs, layers of soot from ancient wildfires, and shifts in ocean chemistry that signal climate change events. Microscopic fossils called foraminifera can be studied to reconstruct past ocean temperatures, while isotopes tell us about ice coverage and atmospheric gases. Some cores stretch back 65 million years or more, a frozen history of a living planet. Extracting them requires precision, patience, and deep-sea drilling vessels that can operate under harsh conditions. But what we gain is priceless, a long silent story of Earth buried beneath kilometers of water and written in dust. Microscopic fossils reveal past worlds now lost to time. Hidden in deep-sea sediment cores are the remains of tiny creatures that once floated near the ocean's surface. Microscopic fossils that hold vast stories. These include foraminifera, tiny shelled organisms that lived for short periods but left behind countless preserved remains. Each species thrived under specific environmental conditions, so by identifying which foraminifera are found in which layers, scientists can reconstruct ocean temperatures, salinity, carbon levels, and climate trends going back tens of millions of years. Some of these layers correspond to global events: the rise of mammals, the retreat of glaciers, the abrupt warming of ancient oceans. What's remarkable is that these fossils are so small, most can't be seen without a microscope, yet they provide one of the most detailed records of Earth's ancient climate systems. They are Earth's diary, written in shells no wider than a grain of sand. Mining the deep could damage fragile ecosystems forever. In recent years, companies and governments have shown growing interest in deep-sea mining, the extraction of minerals and metals from the ocean floor. But with this interest comes serious concern. Much of the deep ocean is fragile and slow to recover, with creatures that grow slowly, reproduce rarely, and depend on specific environmental conditions. Disrupting these ecosystems, even slightly, could cause long-term damage that lasts centuries or longer. Mining machines would stir up thick plumes of sediment, smothering nearby life and possibly spreading for miles. Entire coral communities or microbial colonies could be destroyed before they're even studied. The deep sea isn't just remote, it's vulnerable, and unlike the surface, it can't heal quickly. Scientists and conservationists warn that if we open the deep to industrial mining without full understanding, we may lose one of the most mysterious and valuable parts of the planet forever. Metal nodules litter the seafloor like alien pebbles. Scattered across vast stretches of the deep ocean floor are strange round formations called polymetallic nodules. These rocky lumps look like smooth pebbles or black potatoes, but they're composed of valuable metals like manganese, cobalt, nickel, and copper. Unlike traditional ores, they don't need to be mined from rock. They sit loose on the seabed, waiting to be collected. But these nodules take millions of years to form, growing just a few millimeters per century. They often host unique ecosystems, with tiny organisms clinging to their surfaces or hiding in the sediment around them. To harvest them, machines would need to scrape or vacuum the seafloor, a process that could destroy habitats we've barely begun to understand. These nodules offer a glimpse of planetary time and mineral formation untouched by human hands. They're not just resources, they're geological relics of the deep. These metals are used in phones, batteries, and satellites. The same metals found in deep-sea nodules like cobalt, nickel, and rare earth elements are essential to modern life. They're used in smartphones, electric vehicle batteries, renewable energy systems, and spacecraft electronics. As global demand for these materials increases, especially for clean energy technologies, companies are searching for new sources, and the deep ocean has come into focus. Unlike land mining, which requires digging and refining, these nodules could theoretically be gathered from the seafloor with less overburden. But the trade-off is high: the potential loss of fragile, untouched ecosystems and species unknown to science. The metals may power green technologies, but their extraction could leave a scar on one of Earth's oldest, quietest realms. It's a dilemma that highlights the complexity of sustainability. How do we build a better future without destroying what we've never truly seen? We're debating whether to leave them undisturbed. As interest in deep-sea mining grows, so does the debate about whether it should happen at all. Scientists, policymakers, and conservation groups are asking, should we extract resources from a world we barely understand? Some argue that the metals are essential for a transition to clean energy. Others warn that the cost to ecosystems, biodiversity, and unknown species may be far too high. International bodies like the International Seabed Authority are working to develop guidelines, but many experts say we need more time, more data, and more caution. The deep ocean is slow to change and slow to heal. Damage done there could last for centuries. For now, the nodules sit in silence, scattered like seeds across the seabed, and the question remains unanswered. Will we take them, or will we leave them untouched, a treasure that remains hidden, not because it's forgotten, but because it's protected? Climate change is reaching even the ocean's darkest corners. We often think of the deep sea as untouched, a realm beyond human influence. But even here, climate change is leaving its mark. Warming surface waters affect ocean currents, which in turn alter the movement of heat, oxygen, and nutrients into the depths. Some deep zones are becoming less oxygenated, threatening species adapted to stable, low-oxygen environments. Others are experiencing subtle changes in acidity, temperature, or carbon balance. These shifts may seem small, but in ecosystems that evolved slowly over millennia, even a slight change can be profound. Species may migrate, disappear, or lose the delicate balance they depend on. Coral reefs in the deep are also vulnerable to warming and acidification, just like their shallow water cousins. The deep sea is out of sight, but it is not out of reach. Human impact travels far, and even the abyss is beginning to feel the change. Ocean currents carry heat, salt, and life around the world. Beneath the surface, vast rivers of water move silently through the sea, not just across it, but through it from top to bottom. These thermohaline currents are driven by differences in temperature and salinity, and they form part of what's called the global conveyor belt. As cold, salty water sinks near the poles, it flows deep across the ocean basins, carrying nutrients, carbon, and energy along with it. These deep currents help regulate Earth's climate, distribute marine life, and sustain ecosystems thousands of kilometers away. They can take hundreds of years to complete a single loop. If disrupted by warming or changes in salinity, entire weather patterns could shift. The ocean doesn't just respond to the climate, it helps shape it, and in the deep, the quiet flow of water is one of the most powerful forces on the planet. The deep ocean absorbs massive amounts of carbon. The ocean is one of Earth's greatest carbon sinks, and much of that carbon ends up in the deep sea through a process called the biological pump. Phytoplankton near the surface absorb carbon dioxide during photosynthesis. When these microscopic organisms die, or when they're eaten and excreted, their carbon-rich remains slowly sink through the water column. Over time, this material is buried in seafloor sediments, locking away carbon for centuries or even millennia. The deep sea plays a crucial role in regulating the planet's carbon balance, slowing the pace of atmospheric change. But if warming waters alter ocean circulation or reduce oxygen levels, this delicate balance could shift. The abyss may seem passive, but it is actively working, absorbing, recycling, and storing the byproducts of life above. Its silence hides a crucial function, helping Earth breathe, but its balance may be more fragile than we thought. For a long time, scientists believed the deep ocean was too vast, too cold, and too isolated to be easily affected. But now we know that even small disturbances can ripple through its systems. Changes in temperature or oxygen levels can alter migration patterns, feeding behaviors, and reproductive cycles. Coral reefs that took thousands of years to form may weaken in just decades. Sediment layers show signs of shifts tied to surface changes, clues that the deep responds faster than we once imagined. Because life here moves slowly, it also recovers slowly. A single disturbance could take centuries to heal. The deep ocean may be vast, but it is not invulnerable. It is interconnected, reactive, and surprisingly delicate. And the more we study it, the more we see that protecting it isn't just about saving the deep, it's about safeguarding the planet. Plastic has been found in the most remote trenches. In 2018, researchers exploring the Mariana Trench, the deepest known place on Earth, found something unexpected: a plastic bag. Later, microplastics were detected in sediments, in animals, and even in the stomachs of amphipods from depths exceeding 10,000 mertz. These particles, smaller than a grain of sand, likely drifted down from the surface, carried by currents or attached to sinking organic matter. Once there, they can persist for hundreds of years, entering food webs and potentially altering fragile ecosystems. The discovery was sobering. It showed that no part of the planet is untouched, not even the deepest, darkest trenches. Pollution travels downward quietly, invisibly. The deep sea is vast, but it is not immune. Even here, in the most remote and ancient of places, the footprint of human activity reaches all the way to the bottom. Even deep-sea creatures contain tiny bits of plastic. Recent studies have found microplastic particles inside the bodies of animals living thousands of meters below the surface. These include amphipods, worms, and even some species of deep-sea fish, creatures that have never been near the light, let alone the surface. The plastics come from above, breaking down from bags, fibers, or packaging into microscopic pieces that drift through the water or settle on the seafloor. Deep-sea organisms feeding on marine snow or sediment ingest these particles unknowingly. The long-term effects are still unknown, but scientists worry that plastics may affect reproduction, growth, or digestion in ways we don't yet understand. In a realm shaped by slowness, stability, and balance, even the smallest contaminant can be disruptive. These findings remind us that pollution is not just a surface problem, it sinks and it stays. Some nations are creating deep ocean reserves for protection. In response to growing concerns about exploitation, several countries and international bodies are working to establish marine protected areas that include parts of the deep sea. These reserves are designed to safeguard unique habitats such as hydrothermal vents, cold water coral reefs, and seamount ecosystems from fishing, mining, and drilling. Protecting these areas isn't easy. Enforcement is challenging, and much of the deep ocean lies outside national borders. But the idea is spreading. Some nations have declared large swaths of their ocean territory off-limits to extractive activity, preserving biodiversity and allowing ecosystems to remain untouched. These protected zones offer scientists a chance to study nature as it has existed for millennia, slowly, silently, in its own time. In the vast darkness, reserves may be our best hope of ensuring that some parts of the deep remain wild, quiet, and whole. Life in the deep is stranger than we ever imagined. Every dive into the deep sea reveals something new, and often something utterly bizarre. There are creatures with transparent bodies, fish that walk on fins, worms that resemble feathers, and jellies that light up like fireworks. Some animals live without mouths or stomachs. Others glow, vanish, or unfurl like paper lanterns. Evolution in the deep follows different rules, shaped by darkness, pressure, and isolation. What would be impossible on land becomes commonplace here. The deep isn't just a darker version of the surface, it's a different world altogether, one where life is flexible, strange, and endlessly creative. For every mystery we solve, another arises. For every known species, there may be dozens we've yet to discover. The deep doesn't imitate the surface, it reinvents it. The deep sea begins where sunlight fades to black. Scientists divide the ocean into zones, and the deep sea begins just past the edge of light. This boundary is called the mesopelagic zone, or more poetically, the twilight zone. It begins around 200 Mendel down and stretches to 1000 Mendel, where the last hints of daylight vanish. Below that lies the bathypelagic zone, a place of complete and permanent darkness. No sunlight reaches this depth. Temperatures drop, pressure rises, and life begins to look profoundly different. In these zones, photosynthesis becomes impossible, and most food arrives as a slow drift of falling particles from above. It's a world without seasons, without sky, and without storms. A world where creatures glow, shimmer, or become nearly invisible. It's also not a rare environment. It makes up the vast majority of our planet's living space. The deep sea is not a distant outpost, it's Earth's hidden heart. Its ecosystems could help us understand life on other worlds. Hydrothermal vents, methane seeps, chemosynthetic life. These deep sea systems don't depend on sunlight, and that's exactly why they fascinate astrobiologists. If life can thrive around superheated vents in total darkness, it might also survive in the subsurface oceans of Europa, Enceladus, or even Mars. The deep ocean is our best analogue for alien environments. Studying its microbes and creatures may help us recognize signs of life elsewhere. What kinds of chemistry can support biology? What adaptations allow survival without light? These questions don't just matter to oceanographers, they matter to anyone wondering whether we're alone. The deep is our laboratory for the unknown, and in its strange, quiet corners, we glimpse what life might look like beyond Earth. The deep ocean holds mysteries we haven't even dreamed yet. For all our technology and exploration, the deep ocean remains profoundly mysterious. Over 80% of it remains unmapped, unseen, and unexplored. We don't know what species are out there, how ecosystems are connected, or how many geological wonders lie undiscovered. Every expedition returns with questions we didn't know to ask. The deep resists simplification. It doesn't offer easy answers. Instead, it invites awe, the kind that comes with recognizing how little we truly know. We peer into its darkness with curiosity, wonder, and humility, and in return it offers glimpses of the astonishing. There is no end to its surprises. The deep ocean is not just a place, it's a reminder that the world is still wild, still vast, and still waiting to be discovered. Even in darkness, the deep ocean shines with wonder. No light from the sun ever reaches the deep, yet it glows with bioluminescent creatures, with heat from vents, with the shimmer of strange bodies drifting through silence. But more than that, it glows with meaning. It reminds us that life adapts, persists, and even flourishes in places that seem impossible, that mystery still exists, and that beauty can be found where no one is watching. The deep ocean is full of strange truths, slow rhythms, and living things that defy expectation. And though we may never walk its floor or hear its voices firsthand, we carry its story with us in what we protect, in what we wonder, and in the questions we ask. Even in darkness, the deep ocean shines. The ocean holds 95% of Earth's water. Nearly all of Earth's water, about 95%, lies in the ocean. The lakes and rivers we know, the glaciers and ice sheets that glimmer white in the sun, make up only a small fraction of the total. If all the oceans were drained into a sphere, it would form a ball of water more than 800 miles across, dwarfing everything on the surface. This enormous reservoir is not just a collection of waves. It is a system that cycles water endlessly between sea, sky, and land. It gives us rain, feeds rivers, and sustains every living thing. Without it, there would be no weather, no climate, no life as we know it. The ocean isn't just part of Earth's water cycle, it is the heart of it, a vast engine keeping the entire planet alive. More people have walked on the moon than reached the deepest trench. Since 1969, 12 humans have set foot on the surface of the moon, a place nearly 250,000 miles away. But fewer than a handful have descended into Challenger Deep, the lowest known point on Earth. It's astonishing to think that space travel, something that seems so distant and impossible, has been achieved more often than a full descent into our own oceans. The reason is simple: the deep sea is even more hostile than outer space. The pressure is so extreme that a human body would be crushed instantly without protection. Building vessels that can withstand it is a feat of engineering as great as a rocket launch. Yet, when explorers do reach those depths, they find life clinging to the rocks and drifting through the dark. Proof that even in the harshest corners of Earth, life endures. Most of Earth's volcanic activity happens underwater. When we think of volcanoes, we imagine fiery mountains on land, molten lava spilling into the air. But most volcanic activity on Earth is hidden beneath the sea. Along mid-ocean ridges, molten rock constantly seeps upward, forming new crust. There are countless underwater eruptions happening at any given moment, reshaping the planet's surface far from human sight. Some of these eruptions are so massive, they create new islands rising suddenly from the ocean. Others go unnoticed, their lava cooling instantly in the cold water, creating bizarre formations like pillow basalts, rounded stones that look like frozen bubbles. The ocean floor is a vast volcanic factory, recycling Earth's crust and fueling hydrothermal vents that sustain unique ecosystems. What we see on land is only a fraction of the Earth's fire. The real heart of its volcanic power lies hidden in the sea. The largest living structure on Earth is in the ocean. Stretching more than 1,400 miles along the coast of Australia, the Great Barrier Reef is the largest living structure on the planet. It is so immense that it can be seen from space, a patchwork of coral, sand and sea, glowing in shades of turquoise and green. But the reef is not a single organism. It is built from billions of tiny coral polyps, each no bigger than a grain of rice. Over time, their skeletons accumulate to form towering walls, islands and lagoons, creating a habitat that supports an astonishing variety of life. A quarter of all marine species depend on coral reefs, even though they cover less than 1% of the ocean floor. The Great Barrier Reef is not just beautiful, it is vital, a living city beneath the sea, buzzing with creatures of every imaginable shape and colour. We still discover thousands of new marine species every year. Every year, scientists catalogue thousands of new marine species, from microscopic plankton to deep-sea giants. Some discoveries happen in shallow water, a new species of fish, shrimp or coral, hiding in plain sight among reefs. Others emerge from the deep, carried up by research submersibles or fishing nets, bizarre creatures with glowing lures, transparent bodies or teeth like needles. And still, experts believe we've only identified a fraction of what's out there. By some estimates, as many as 2/3 of marine species remain unknown to science. It's as if every time we peek beneath the waves, the ocean reminds us that its secrets are endless. In a world where so much feels mapped and measured, the ocean remains a frontier, a reminder that discovery is not a thing of the past, but something happening every single day. Some creatures glow in the dark without any light. Bioluminescence is one of the ocean's most magical tricks. Countless creatures, from tiny plankton to large squid, can produce their own light. Some flash suddenly to startle predators, others glow gently to attract mates or lure prey. A swarm of plankton stirred by waves can make the sea shimmer as if filled with stars. Deep below, anglerfish dangle glowing lures, tricking victims into swimming close. The light is not reflected from the sun, but created through chemical reactions inside the animals themselves. Tiny sparks of energy made visible in the blackness of the deep. These glows are signals, warnings, disguises and traps. Entire ecosystems are lit not by the sun, but by the creatures themselves, turning the dark ocean into a shifting galaxy of living stars. It's a reminder that even in darkness, life finds a way to shine. The largest migration on Earth happens underwater every night. Every evening, as the sun sinks and darkness spreads across the sea, billions of tiny organisms rise from the depths toward the surface. This event, called the diel vertical migration, is the largest daily movement of life on the planet. Small plankton drift upward to feed on microscopic plants in the shallows. Behind them follow fish, squid, and predators that feed on the plankton. Then come even larger hunters drawn into the chain of life. At dawn, the entire mass retreats again into the dark, avoiding the gaze of predators from above. It happens everywhere, every night, yet almost no one ever sees it. From the surface, the water may look calm and empty, but beneath, a hidden tide of living things flows upward and downward, as steady as the rhythm of breathing. It's the heartbeat of the ocean, pulsing endlessly in time with the sun. There are lakes and rivers at the bottom of the sea. It sounds impossible, but beneath the ocean, there are places where water gathers into pools and flows like rivers. These strange formations, known as brine pools, are created where super salty water seeps from the seafloor. Because the brine is so much denser than the surrounding seawater, it settles into depressions, forming shimmering lakes at the bottom of the ocean. Some even have shorelines, waves, and currents of their own. To visiting submarines, they look like ghostly ponds lying inside the sea, surreal and otherworldly. For the creatures that live nearby, these pools can be deadly. The salt levels are so extreme that most life cannot survive within them. Yet at the edges, strange communities flourish, adapted to thrive at the boundary of two very different worlds. In the deepest dark, the ocean hides landscapes that feel more like alien planets than Earth. The ocean floor is spreading apart beneath our feet. Far below the waves, the sea floor is slowly splitting open. Along mid-ocean ridges, molten rock wells up from beneath the crust, creating new ocean floor and pushing the plates of Earth apart. This process, called seafloor spreading, is one of the fundamental engines of our planet. It is happening constantly, day and night, reshaping the globe at a pace too slow for us to feel. Over millions of years, it has opened entire oceans, shifted continents, and built towering underwater mountains. The Mid-Atlantic Ridge, where the seafloor is spreading, runs for tens of thousands of miles, longer than any mountain range on land. Each moment, new Earth is born here, rock that will someday rise into continents, islands, or mountains. Though hidden under miles of water, the process beneath the sea is what gives shape to the world we know. Earthquakes and tsunamis begin in the ocean's depths. Many of the most powerful earthquakes don't begin on land, but deep beneath the ocean floor along shifting fault lines where tectonic plates grind against one another. When these plates suddenly slip, the energy released can ripple upward into the sea, displacing entire walls of water. This movement can create tsunamis, waves that travel across entire ocean basins at jet speeds, carrying unimaginable energy. At sea, a tsunami might pass almost unnoticed, a slight rise of the water, but as it approaches shore, it builds into towering walls that can reshape coastlines in moments. Scientists watch these fault zones carefully, using seismographs and ocean buoys to warn of impending danger. The power unleashed reminds us that the ocean is not just water, but a restless surface stretched across a living, shifting Earth, always moving, always alive beneath our feet. Vast underwater canyons rival the Grand Canyon. Hidden beneath the waves are enormous canyons carved into the continental shelves. These submarine canyons can plunge thousands of feet deep, rivaling or even surpassing the scale of the Grand Canyon on land. Formed by ancient rivers, landslides, and currents, they channel sediments from the coast down into the abyssal plains of the ocean. Monterey Canyon off the coast of California is more than twice as deep as the Grand Canyon, descending straight into the sea. Exploring them is like looking into enormous scars on the edge of the continent, places that hold clues to Earth's history and the movements of water through time. These canyons are also rich ecosystems, sheltering life in their sheltered walls, where nutrients gather and creatures thrive. Out of sight, these valleys reveal that Earth's greatest landscapes are not only on land, but also beneath the waves. The ocean produces more oxygen than the Amazon rainforest. When people think of the lungs of the planet, they often picture the Amazon rainforest. But in truth, most of the oxygen we breathe comes from the ocean. Tiny organisms called phytoplankton drift through the upper layers of the sea, turning sunlight into energy through photosynthesis. In the process, they release oxygen into the water and air. These microscopic plants are so numerous and their reach so vast that together they produce more than half of Earth's breathable oxygen. Every breath we take carries the imprint of the sea. From space, vast blooms of plankton can be seen as green swirls spreading across the ocean surface, covering areas larger than countries. Though invisible to us most of the time, these tiny drifters quietly sustain life on Earth, proving that the greatest forests are not always made of trees. Tiny organisms in the sea influence Earth's climate. Microscopic life in the ocean doesn't just produce oxygen, it helps regulate the climate itself. Phytoplankton absorb carbon dioxide from the atmosphere as they grow, pulling it down into the ocean. When these tiny organisms die, some of that carbon sinks with them into the deep sea, where it can remain locked away for thousands of years. This process, sometimes called the biological pump, is one of Earth's most powerful climate regulators. Without it, the atmosphere would hold far more carbon dioxide, and the planet would be much hotter. These organisms are so small that billions can fit in a teaspoon of water, yet together they shift the balance of the entire planet. It's a reminder that even the tiniest forms of life, invisible to the naked eye, can shape the destiny of a world. The ocean's currents act like planet-sized conveyor belts. Beneath the surface, the ocean is always moving. Great currents loop around entire basins, carrying warm water from the tropics toward the poles, and returning cold water back again. This circulation, sometimes called the global conveyor belt, is essential to life on Earth. It balances temperatures, moves nutrients, and even shapes the climate on continents far from the shore. The Gulf Stream, for example, carries warmth across the Atlantic, keeping Europe's climate far milder than it would otherwise be. These currents are driven by a delicate balance of heat, wind, and salinity, and they can take centuries to complete a single cycle. Each wave that breaks on the beach is connected to these hidden rivers, linking every coast on Earth. The ocean's conveyor belt is not just a flow of water, but a flow of life, warmth, and balance across the entire planet. Some waves travel the entire width of an ocean basin. When wind blows across the sea for long enough, waves begin to build. Most break on a nearby shore, but some, called swell waves, can travel for thousands of miles across entire ocean basins. A storm in the Southern Ocean can send waves rolling all the way to distant beaches in South America, Africa, or even the Pacific. These waves move with steady rhythm, carrying the memory of the storm that birthed them across half the world. Surfers sometimes ride swells that began as storms weeks earlier and oceans away. To stand on a shore and feel the pulse of these waves is to connect with distant places, knowing that the energy began far beyond the horizon. The sea itself becomes a messenger, sending whispers of far-off storms across the globe, one rolling crest at a time. The tallest waves ever recorded happened at sea. Most ocean waves rise just a few feet high, breaking gently on beaches. But at sea, under the right conditions, waves can grow to staggering heights. The tallest wave ever recorded by instruments was a monstrous wall more than 100 feet high, taller than a 10-story building. These giants form during violent storms when powerful winds and currents align, stacking energy into a single crest. To sailors, such waves are awe-inspiring and terrifying, towering walls of water that seem capable of swallowing ships whole. Yet they are part of the ocean's natural rhythm, a reminder of its raw and untamed power. For every calm shoreline, there are wild places where the sea lifts itself into mountains, proving that water in motion can rival the greatest forces on land. Rogue waves can rise without warning. Out in the open sea, Sailors sometimes speak of a wave that comes out of nowhere, a solitary wall of water rising like a liquid cliff. These are called rogue waves, and for centuries they were thought to be sailors' tall tales. But modern instruments have confirmed their reality. Rogue waves can tower more than 100 feet high, twice as tall as nearby waves, forming suddenly from the merging of smaller swells. They can appear under clear skies, or strike in the middle of a storm, then vanish just as quickly. Ships that encounter them often report being lifted like toys, their decks briefly facing walls of water higher than lighthouses. Though we now know they exist, their exact triggers remain mysterious. A reminder that the ocean can surprise us at any moment with a power that defies prediction. The ocean has waterfalls taller than anything on land. It seems impossible, but deep beneath the waves, water itself can fall like rain, tumble like rivers, and cascade like waterfalls. One of the largest is hidden beneath the Denmark Strait between Greenland and Iceland. There, cold, dense water from the Arctic sinks beneath warmer water from the Atlantic, creating a massive downward flow. This underwater waterfall plunges more than 2 miles, nearly 4 times taller than Angel Falls, the tallest waterfall on land. Yet, because it happens in the dark deep sea, it's invisible to human eyes. These underwater cascades help circulate nutrients and regulate global currents, playing a quiet but essential role in Earth's climate. Imagine a waterfall so vast that it could swallow mountains, rushing downward unseen for centuries, shaping the hidden world beneath the waves, a secret cascade flowing endlessly in the dark. Some deep-sea creatures survive pressures that would crush submarines. At the bottom of the ocean, the pressure is beyond comprehension. For every 30 feet of depth, the pressure increases by the weight of Earth's atmosphere. By the time you reach the Challenger Deep, it's over 1,000 times what we feel at the surface. A steel submarine would crumple like a soda can. Yet life still flourishes there. Others can live without sunlight for their entire lives. On land, sunlight is everything. Plants need it, animals chase it, and our days are guided by it. But in the abyss of the ocean, light never arrives. And still, life thrives. There are fish that never see the sun, crustaceans that navigate only by touch, and entire colonies of bacteria that eat chemicals instead of light. In caves, trenches, and under layers of ice, these creatures carry on entire lifetimes in a world of endless night. Hydrothermal vents host ecosystems powered by chemistry, not sunlight. In the late 1970s, scientists exploring the deep sea discovered something astonishing: towering chimneys of rock spewing black, boiling water into the abyss. These were hydrothermal vents, cracks in the seafloor where seawater seeps down, heats near molten rock, and bursts back out, filled with minerals. Around them, life thrives, not by sunlight, but by chemistry. Tube worms can grow taller than a human in complete darkness. In the black depths near hydrothermal vents, forests of white and red shapes rise from the seafloor. These are giant tube worms, some of them taller than a person. Unlike most animals, they have no mouth and no stomach. Instead, their bodies house special bacteria that feed them by turning the hot, mineral-rich vent water into food. Some creatures thrive in temperatures hot enough to melt lead. Near the vents of the deep ocean, water can reach temperatures of more than 700 Earth, hotter than molten lead would be on the surface. You might think nothing could live in such extremes, but life has a way of surprising us. Certain bacteria, known as extremophiles, thrive in this scalding water, using chemical reactions to survive where everything else would burn away. Some even form the base of entire food webs, supporting larger creatures that cluster around the vents. These organisms challenge our very definition of what life can endure. If life can exist in boiling, pressurized darkness on Earth, then perhaps it could also exist in the hidden oceans beneath the icy crusts of moons like Europa or Enceladus. The deep sea doesn't just teach us about our own planet. It expands our imagination for life everywhere. Others live in water cold enough to freeze skin instantly. At the other extreme, some ocean creatures live in water so cold it hovers just above freezing. In the deep Antarctic seas, fish swim through icy darkness where the temperature never rises above the freezing point of fresh water. To survive, many produce natural antifreeze proteins in their blood, preventing ice crystals from forming inside their bodies. These adaptations allow them to live in conditions that would kill most other animals in moments. The water is so cold it could freeze human skin on contact. Yet life continues in delicate, beautiful forms: pale fish with transparent bodies, slow-moving starfish, and even entire communities beneath the ice-covered surface. The deep ocean reminds us that what feels impossible to us is ordinary to other creatures. To them, this frigid darkness is not a prison, but home, a place where life has carved out its own quiet niche. There are fish that can walk on land. It sounds like something out of a dream. A fish climbing out of the water and walking across the land. Yet in parts of the world, this is reality. Mud skippers are small fish that can use their fins almost like legs, hauling themselves up onto mudflats when the tide recedes. They can breathe air through their skin and even through the lining of their mouths and throats, allowing them to spend hours outside the water. On land, they hop, climb, and even fight for territory, their eyes blinking above the mud like tiny periscopes. Watching them scurry across the ground is like catching a glimpse of evolution in progress, a reminder of the time when the very first creatures made the daring leap from sea to land. In every movement, mud skippers carry with them a whisper of Earth's ancient story of transformation. Some squid can fly through the air, above the waves. The ocean is full of surprises, and one of the most delightful is the flying squid. These remarkable creatures can launch themselves from the sea, spreading their fins like wings and gliding through the air. By rapidly forcing water out of their bodies, they create a jet that propels them upward, sometimes soaring more than 100 feet above the waves. To an observer, it looks as though a school of fish has suddenly taken flight, their silvery bodies flashing in the sunlight before splashing back into the sea. Scientists believe they do this to escape predators or to travel quickly across the surface. Whatever the reason, the sight blurs the boundary between sea and sky. For a few moments, these squid live in two worlds at once, creatures of the deep who borrow the freedom of the air before returning to the water's embrace. The giant squid was once thought a myth. For centuries, sailors whispered about monstrous creatures lurking in the deep, tentacled beasts so large they could drag entire ships beneath the waves. Many dismissed these stories as superstition, the stuff of sea shanties and fear. But then in the modern era, evidence began to surface. Enormous sucker-marked scars on whales, mysterious tentacles washing ashore, and finally, photographs of the creature itself. The giant squid is real, a ghostly animal with eyes the size of basketballs and tentacles stretching as long as a bus. Rarely seen alive, it usually remains deep in the twilight ocean, far from human eyes. Its discovery transformed legend into reality, a reminder that myth often hides a kernel of truth. Even today, to glimpse a giant squid in its natural world is to witness the boundary between human imagination and Earth's hidden wonders dissolving. The colossal squid has eyes the size of dinner plates. If the giant squid seems extraordinary, its even larger cousin, the colossal squid, is almost beyond belief. This deep-sea giant has the largest eyes of any animal known, each one as big as a dinner plate, up to a foot across. In the blackness of the Southern Ocean, such enormous eyes are not a luxury, but a necessity. They allow the squid to detect faint traces of light, whether from the glimmer of bioluminescent creatures or the faint glow of the moon filtered miles through the sea. These eyes help it detect predators like sperm whales and prey in the endless dark. The colossal squid itself may grow to lengths exceeding 40 feet, with tentacles armed with rotating hooks, and yet, despite its size, it remains mysterious. Very few have ever been seen, reminding us that even the largest creatures can hide in the deep. The blue whale is larger than any dinosaur ever was. When people think of Earth's greatest giants, dinosaurs often come to mind, but the truth is, the largest creature to ever live on our planet is alive today, the blue whale. Stretching up to 100 feet long, and weighing as much as 200 tons, a single blue whale outweighs even the mightiest sauropod dinosaur. Its tongue alone can weigh as much as an elephant, and its mouth could hold an entire bus. Despite its size, the blue whale survives by eating some of the smallest creatures in the ocean, tiny shrimp-like krill, which it gulps by the ton. When a blue whale surfaces and exhales, its spout of mist can rise higher than a 2-story house. To see one in the open ocean is to glimpse the scale of life itself, vast, majestic, and humbling beyond words. A blue whale's heart is the size of a small car. Inside the enormous body of a blue whale beats a heart unlike any other on Earth. It is the size of a small car and can weigh more than 400 pounds. With each slow, thunderous beat, it pumps gallons of blood through the whale's massive body. You could fit a small child inside the chambers of this heart. Yet, despite its size, the whale's pulse is surprisingly slow, sometimes as little as 2 beats per minute when it dives deep in search of food. Only when it surfaces for air does the pace quicken, racing to pump oxygen through its body. This mighty heart sustains the largest animal our world has ever known, powering journeys across oceans and dives thousands of feet below the waves. Listening to its rhythm would be like hearing the drumbeat of the ocean itself. Whale songs can travel across entire ocean basins. Humpback whales are known for their haunting, beautiful songs, long, complex sequences of sound that can last for hours. These songs are not just noise, they are structured, repeating patterns, almost like music. Even more extraordinary, their low rumbling notes can travel astonishing distances underwater. In some cases, a whale's song can be heard thousands of miles away across entire ocean basins. Imagine a whale singing in the Pacific and another hearing its voice across the vast blue expanse. Scientists believe these songs may be a form of communication, a way of attracting mates, or even a cultural tradition passed from whale to whale. To hear one is to feel as though the ocean itself has found a voice, slow, deep, and resonant, carrying messages across the largest stage in the world. It is music written in water and time. Dolphins have names for each other. Among dolphins, communication is astonishingly complex. These intelligent mammals whistle, click, and chirp in patterns that researchers have studied for decades. One of the most fascinating discoveries is that dolphins appear to give each other names. Each dolphin develops a unique signature whistle, a sound that identifies them individually, much like a name does for us. Other dolphins use these whistles to call them, sometimes even imitating the sound to get their attention. It's as though dolphins carry a spoken identity, a vocal label recognized across their social groups. This discovery challenges the way we think about language and self-awareness in animals. To know your own name, and to respond when called, suggests a sense of individuality we often reserve for humans. In the quiet underwater world, dolphins are not just whistling at random. They are calling to each other by name. Some whales can hold their breath for over 2 hours. For humans, holding our breath for a minute or two feels like an achievement, but some whales can dive for more than 2 hours without coming up for air. The champion is the Cuvier's beaked whale, which has been recorded diving to depths of nearly 2 miles and staying submerged for over 120 minutes. To accomplish this, whales slow their heart rate dramatically, conserve oxygen in their muscles, and allow certain organs to temporarily shut down. They sink into the dark with calm precision, navigating by sound, chasing squid and fish in the deep. When they finally return to the surface, the rush of their exhaled breath explodes into the air, like a release of hidden time. These dives remind us that the limits we feel in our bodies are not universal. Life finds ways to stretch endurance into the unimaginable. A sperm whale's clicks are louder than a jet engine. The sperm whale is famous for its immense size and deep dives, but it also holds another record, the loudest sound produced by any living creature. When a sperm whale clicks to communicate or hunt, the sound can reach over 200 dB, louder than a jet engine at takeoff. These clicks are used like sonar, bouncing off objects in the dark ocean depths and returning echoes that help the whale see with sound. They can also carry messages across miles of water, allowing whales to communicate even in the vast silence of the deep. For humans, being close to such a sound would be overwhelming, even dangerous. But for sperm whales, it is a natural language woven into their lives. In the stillness of the ocean's depths, their voices echo like thunder, reminding us how alive the silent dark truly is. Jellyfish have drifted through Earth's oceans for over 500 million years, long before the first forests grew. Before even the earliest dinosaurs walked the Earth, jellyfish were already drifting through the seas. Fossil evidence shows they have existed for more than 500 million years, making them some of the oldest creatures on Earth. They have no bones, no brains, and no blood. Yet they have survived countless extinctions, adapting to every change our planet has faced. Their bodies are made mostly of water, delicate and translucent, yet their design has endured for 500 million years. In many ways, they are living fossils, windows into a time when Earth was young, and the seas were the center of life. Watching a jellyfish drift, pulsing gently with light and motion, is like seeing the past itself alive in the present, a reminder of how ancient and resilient life in the ocean can be. Some jellyfish are effectively immortal. Among the many strange abilities of jellyfish, one species has earned the nickname the immortal jellyfish. Known as Turritopsis dohrnii, it has the extraordinary ability to reverse its own aging process. When stressed, injured, or near death, it can transform its adult body back into a younger polyp stage, essentially starting its life cycle all over again. In theory, this means it could live forever, avoiding death by continually rejuvenating itself. In practice, most don't survive indefinitely, as predators and disease still claim them. But the very possibility of biological immortality is staggering. This small, delicate creature drifting unnoticed through the oceans may hold secrets to life extension that humans have only begun to imagine. It is as though the ocean itself whispered a secret, that time doesn't always have to flow in only one direction. The Portuguese man-of-war isn't a single creature. At first glance, the Portuguese man-of-war looks like a single jellyfish drifting with a delicate purple-blue sail above the waves. But this is no lone organism, it's a colony. The man-of-war is made of many individual animals called zooids that live together as one. Each zooid has a specific role. Some handle feeding, others reproduction, and others defense. None can survive alone, but together they form a floating organism that can stretch more than 100 feet, with venom-filled tentacles. The man-of-war has no brain, no skeleton, and no heart. Yet it hunts with deadly precision, paralyzing fish and sweeping them into its shared digestive system. It is a living lesson in cooperation, a reminder that sometimes survival depends not on individual strength, but on the ability to become part of something larger than yourself. Some fish can change gender during their lives. In the ocean, even identity can be fluid. Many fish species are not locked into being male or female for life. They can change. Clownfish, for example, live in groups led by a dominant female. If she dies, the largest male changes sex and takes her place, becoming the new matriarch. Wrasses, another group of fish, often switch from female to male when it benefits the survival of the group. This ability ensures balance, allowing populations to adapt when circumstances shift. The process is not just behavioral, but biological. Hormones trigger transformations that reshape organs and change the way the fish function. To us, the idea of such a transformation feels impossible, but in the sea, change is simply part of life. The ocean teaches us that identity can be more flexible than we imagine, a fluid dance like the tides themselves. The clownfish needs its anemone to survive. Clownfish are instantly recognizable, with their bright orange bodies striped in white and black, but their most remarkable trait is their partnership with sea anemones. These anemones are covered in stinging tentacles that can paralyze most fish on contact. Yet clownfish swim freely among them, immune to their sting. In return, the clownfish cleans the anemone, driving away parasites and even luring prey into its deadly grasp. The anemone protects the clownfish from predators, while the clownfish ensures its partner stays healthy and well fed. Neither could thrive as well without the other. This mutual bond is an elegant reminder that survival in the ocean is not always about competition. Sometimes it is about forming alliances. When we watch a clownfish darting safely among the waving arms of its host, we are seeing trust itself, woven into the fabric of life beneath the sea. Sharks existed before trees did. Sharks are among the oldest survivors on Earth. They first appeared more than 400 million years ago, long before the first trees grew on land. While forests are relatively recent in Earth's history, sharks were already prowling the oceans when land was barren and lifeless. Over time, they have survived multiple mass extinctions, outliving the dinosaurs and adapting to new worlds as continents shifted and climates changed. Their bodies, honed by evolution, are so effective that they've remained relatively unchanged for hundreds of millions of years. When you see a shark gliding silently through the water today, you are watching a living relic, a design so perfect it has outlasted entire ages of Earth's history. They are reminders that some of the planet's greatest survivors are not on land at all, but in the endless depths of the sea. Some sharks can detect a single drop of blood in an Olympic pool. Sharks are legendary for their sense of smell, and the truth is even more extraordinary than the myth. Many shark species can detect a single drop of blood in a body of water as large as an Olympic-sized swimming pool. Their nostrils are lined with sensory cells so sensitive that they can pick up tiny chemical traces from miles away. This ability helps them track wounded prey through the vastness of the ocean where visibility is often poor. It also means they can detect the faintest signals of life in the water, guiding them through the dark. While the idea has fueled countless stories of terrifying predators, it's also a marvel of nature's design, a reminder of how finely tuned senses can become when survival depends on them. For sharks, smell is not just a sense, it's a way of seeing the ocean. Others glow with bioluminescence. While many people picture jellyfish when they think of glowing sea life, sharks too can shine in the dark. Certain species, like the lantern shark, produce bioluminescent light along their bellies. These glowing patterns help them camouflage by blending into the faint light from above, making them nearly invisible to predators below. Some species also use their glowing stripes to communicate with one another, perhaps signaling mates or warning rivals. What's remarkable is that these sharks live in the deep sea, where sunlight never reaches. Their light is entirely their own, a living lantern that illuminates the dark. Scientists have only recently begun to understand the chemistry behind this glow, and the mystery is still unfolding. Imagine a predator gliding silently through the abyss, its body outlined with a ghostly blue shimmer. The ocean never stops surprising us with its strange luminous wonders. The Greenland shark can live for more than 400 years. In the icy waters of the North Atlantic lives one of the most extraordinary creatures on Earth, the Greenland shark. Slow-moving and almost prehistoric in appearance, these massive sharks can live for more than 4 centuries, making them the longest-lived vertebrates known. Some individuals alive today may have been swimming through the deep when Shakespeare was writing his plays, or even when Leonardo da Vinci was sketching his inventions. Their secret lies in their slow metabolism, a result of the frigid waters they inhabit. Moving sluggishly through the darkness, they conserve energy and live at a pace so unhurried it stretches across centuries. They grow only a few centimeters each year, eventually reaching lengths of over 20 feet. To imagine a creature that has lived for hundreds of years, quietly drifting beneath Arctic ice, is to glimpse time itself flowing slowly in the sea. Hammerhead sharks see the world in stereo vision. Few creatures are as instantly recognizable as the hammerhead shark. With wide hammer-shaped heads stretching like wings, they seem almost designed by an artist's imagination. But their unusual shape is not just for show. It gives them a kind of stereo vision. With eyes positioned far apart, a hammerhead can see more of the world around it, overlapping its fields of vision to judge distances more accurately. This makes it an exceptional hunter, able to track the movements of prey with precision. The wide head also holds special sensory organs that detect faint electrical signals given off by other creatures, allowing the hammerhead to sense hidden fish buried in the sand. In the open ocean, this combination of sight and sensing turns the hammerhead into one of nature's most extraordinary predators, moving with both elegance and eerie awareness through the water. The megalod once ruled the seas. Millions of years ago, the oceans were ruled by a predator so enormous it dwarfed even the great white shark. This was the megalodon, a shark that could grow more than 60 feet long, with jaws powerful enough to crush the bones of whales. Its teeth, some as large as a human hand, are still found in sediments around the world, relics of a creature that once dominated the seas. For 20 million years, megalodons were the undisputed rulers of the ocean, until changing climates and competition from other predators brought them to extinction about 3 million years ago. Even so, the thought of a shark the size of a bus patrolling the seas is enough to stir awe and fear. The megalodon may be gone, but its legend lives on in the fossilized teeth that wash up on beaches like ancient treasures. Some modern fish still carry ancient features from those times. Though megalodons disappeared millions of years ago, traces of ancient seas still live on in modern fish. The coelacanth, for example, was thought to be extinct for over 65 million years, until one was found alive off the coast of South Africa in 1938. This strange lobe-finned fish looks almost unchanged from fossils dating back hundreds of millions of years. Its fins resemble primitive limbs, hinting at the evolutionary steps that once carried fish onto land. Other species, like sturgeon and hagfish, retain ancient features that connect them to some of the earliest vertebrates. These living fossils are reminders that evolution doesn't move at the same pace everywhere. Some creatures adapt and change quickly, while others remain stable for eons, surviving just as they are. The ocean is a time capsule, holding echoes of life's earliest experiments still swimming today. The ocean holds vast reservoirs of frozen methane. Far beneath the seafloor, locked within icy crystals, lies an enormous storehouse of energy. Methane hydrates. These are strange structures where methane gas is trapped inside cages of frozen water, forming a substance that looks like ice, but burns if touched by flame. Scientists estimate there may be more carbon stored in these hydrates than in all known fossil fuels on land. If released suddenly, they could warm the planet dramatically, but they also represent a potential energy source, a frozen fuel waiting in the dark. The hydrates are found in deep sediments and along continental slopes where pressure and cold keep them stable. They are fragile though, and a change in temperature could set them free. It is humbling to think that beneath the calm ocean floor lies a hidden reservoir that could change the course of Earth's climate and energy future. Underwater landslides can trigger massive tsunamis. We often think of tsunamis as being caused by earthquakes, but the ocean has another way of creating these enormous waves: underwater landslides. Along the steep slopes of submarine canyons, vast amounts of sediment can suddenly give way, tumbling downward into the abyss. This sudden movement displaces huge volumes of water, sending shock waves outward as towering waves. Some of the largest tsunamis in history may have been triggered this way, their origins hidden beneath the sea. One ancient landslide off the coast of Norway, known as the Storegga Slide, caused waves hundreds of feet high that swept across the North Atlantic thousands of years ago. These underwater avalanches still occur today, though most are smaller and unnoticed by people on land. They remind us that the ocean floor is not fixed or stable, but alive with movements capable of reshaping coastlines in a single moment. Earth's magnetic field leaves stripes on the ocean floor. The ocean floor is like a giant tape recorder, preserving a record of Earth's magnetic history. As molten rock wells up at mid-ocean ridges and cools, tiny magnetic minerals inside it align with Earth's magnetic field, freezing in place like tiny compasses. Over millions of years, as the planet's magnetic field has flipped with the North and South poles trading places, these rocks have recorded the changes. The result is a series of stripes across the seafloor, alternating bands of magnetic orientation that stretch for thousands of miles. When scientists first mapped these patterns, it provided stunning evidence that the continents move and the seafloor spreads apart. The ocean floor is not just a landscape, It is a history book written in stone, carrying the memory of Earth's shifting poles and drifting continents across the vast expanse of time. Black smokers release metal-rich fluids like underwater forges. In the deep ocean along volcanic ridges, there are vents known as black smokers. They look like chimneys rising from the seafloor, belching out dark plumes of superheated water. This water, nearly as hot as molten lead, is filled with dissolved minerals and metals. When it gushes into the cold seawater, the minerals solidify instantly, falling back down in clouds that look like smoke. Around these vents, life thrives in surprising abundance. Giant tube worms, clams, and swarms of shrimp feed on bacteria that use the minerals for energy. In a place without sunlight, these ecosystems are powered by the Earth's inner heat. Black smokers are also thought to be similar to the environments where life first began on Earth. They are underwater forges, reshaping the seafloor, fueling life, and reminding us that creation can spring from even the most extreme conditions. The deep sea is the largest habitat on Earth. When we imagine Earth's habitats, we often picture forests, deserts, or grasslands. But the largest habitat of all lies beneath the waves, the deep sea. Everything below about 200 meters, where sunlight fades away, makes up the vast majority of our planet's living space. It stretches across more than half the planet's surface and plunges miles deep. Within it live countless species, many still unknown, adapted to darkness, pressure, and cold. It is a place of quiet but constant motion, where slow currents move nutrients, and where life takes on forms unlike anything found on land. From glowing jellyfish to colossal squid, the deep sea is Earth's hidden wilderness, the biggest ecosystem we have, and one we still barely understand. To drift there in imagination is to float in the planet's greatest, most mysterious home. Some deep-sea fish carry lanterns on their heads. In the twilight and midnight zones of the ocean, where sunlight cannot reach, some fish create their own light. The most famous of these are the anglerfish, which carry glowing lures dangling from stalks on their heads. These lanterns are produced by bioluminescent bacteria living in a special pouch at the tip of the stalk. The fish waves this glowing orb in the dark like a flickering candle. Smaller creatures, curious or drawn to the light, swim closer and are swallowed in an instant. Some anglerfish can even control the brightness of their lure, turning it on and off like a flashlight. To us, it might seem like a fairy tale image, a creature carrying its own lantern through the eternal night. But in the deep ocean, it is simply survival, proof of how life adapts in the most extraordinary and inventive ways. The fang-toothed fish has teeth too large for its own mouth. Deep in the ocean lives a creature so fierce-looking it seems born of nightmares. The fang-toothed fish. Its teeth are so enormous relative to its body that they can't even fit comfortably inside its mouth. Instead, special sockets in the roof of its jaw hold the teeth in place when it closes. Despite its terrifying appearance, the fangtooth is not a giant. Most grow only to about 6 inches long, but what they lack in size, they make up for in design. Their needle-sharp teeth ensure that any prey unlucky enough to come close cannot escape. In the darkness of the deep sea, where food is scarce and encounters are rare, such adaptations can mean the difference between survival and starvation. The fangtooth is a reminder that the ocean's depths are filled with creatures that seem almost too strange to be real. Gulper eels can swallow prey larger than themselves. The gulper eel is a creature of extremes. Its body is long and slender, but its mouth is enormous, ballooning outward like a vast dark net. This unique adaptation allows it to swallow prey much larger than itself, even creatures half its own length. The gulper eel lives in the deep ocean where meals are scarce and unpredictable. When something edible comes within reach, the eel opens its enormous jaws, expanding them into a gaping void that can engulf almost anything. Its body stretches to accommodate the meal, allowing it to feast even when prey is rare. The gulper's tail often glows with a bright pinkish light, perhaps to attract unsuspecting victims. Watching one open its mouth is like watching a shadow turn into a cave. The ocean itself seems to gape open, ready to swallow whatever drifts too close. Anglerfish use glowing lures to attract victims. Perhaps no creature better embodies the eerie wonder of the deep sea than the anglerfish. With needle teeth and a huge mouth, it looks fearsome, but its most famous feature is the glowing lure that dangles from its forehead. This lure is filled with bioluminescent bacteria, glowing softly in the darkness. Smaller fish, mistaking it for food, swim toward the light, only to be caught in the anglerfish's jaws. Female anglerfish are the hunters, growing much larger than the males. In some species, tiny males fuse permanently to the females, becoming little more than living sources of sperm. It's a bizarre strategy, but it ensures that when a female finds food in the vast dark ocean, she also has a mate attached. The anglerfish reminds us that in the deep sea, life is both terrifying and ingenious, evolving in ways we can barely imagine. Some deep-sea creatures are transparent as glass. In the darkest waters, camouflage takes on strange and beautiful forms. Many deep-sea creatures are nearly invisible, their bodies transparent as glass. Some jellyfish are so clear you can see their internal organs glowing faintly within. Certain fish, like the glass squid, have bodies that are almost entirely see-through, with only their eyes visible as faint shadows. This invisibility protects them from predators in the vast emptiness of the deep, where there are few places to hide. Light passes straight through them, making them vanish into the water around them. For humans, it's like seeing a living ghost, a creature that is present and yet barely there. In a realm without sunlight, where survival depends on remaining unseen, transparency is the perfect disguise. The ocean is full of these ghostly beings, drifting quietly through the blackness, like whispers of water itself. Others have skin so black they absorb nearly all light. In the deep ocean, some creatures have evolved to disappear in a different way. Instead of becoming transparent, they cloak themselves in skin so black that it absorbs nearly every photon of light. These ultra-black fish have skin that traps over 99% of light, making them nearly invisible even when bioluminescent creatures shine nearby. To a predator searching with glowing lures or sensitive eyes, the fish vanish against the background of darkness. Their skin acts almost like living velvet, scattering light inwards so nothing reflects back. Even cameras designed for the deep struggle to capture their forms, these creatures float like moving shadows, perfectly hidden in the abyss. It is camouflage taken to the ultimate extreme, not by blending in with their surroundings, but by becoming darker than the deep itself. A reminder that invisibility is not just fantasy, but a survival tool of the sea. The ocean floor holds more gold than all the mines on land. It may surprise you to know that the ocean is filled with gold, far more than all the mines ever dug on land. Dissolved in seawater and trapped in sediments across the ocean floor lies an estimated 20 million tons of gold. But this treasure is spread so thin that extracting it is nearly impossible. Each litre of seawater contains only a few billionths of a gram of the precious metal. Still, the thought is staggering. Beneath the waves, glittering in the dark, lies more gold than humans have ever held in their hands. Some scientists imagine technologies that might one day make this treasure accessible, though for now it remains far beyond our reach. The ocean hides riches not in sparkling piles, but in endless, invisible abundance, a treasure chest so vast that it reminds us how small our own wealth truly is. There are lost shipwrecks scattered across the sea. Beneath the waves, hidden from sight, lie the remains of countless ships. Some sank in storms, some in battle, and others simply vanished into the deep without a trace. It's estimated that more than 3 million shipwrecks rest on the seafloor, ranging from ancient wooden vessels to modern steel giants. Each one is a time capsule, preserving a moment of history beneath layers of sand and coral. Some hold cargoes of gold and silver, others everyday objects, pottery, tools and coins that whisper stories of lives long past. Many wrecks become artificial reefs, their broken hulls now home to fish, corals and sea turtles. Divers sometimes describe the eerie quiet of exploring these sunken ships as if they're walking through a memory. The ocean is both graveyard and guardian, holding the remains of human journeys in its timeless, watchful silence. Some are preserved perfectly for centuries in cold depths. In the coldest, darkest corners of the sea, time seems to pause. Shipwrecks that would quickly decay on land can remain intact for centuries underwater. The icy depths slow decay, and the lack of oxygen prevents wood and metal from rotting. Off the coast of Sweden, a 16th century warship called the Vasa was raised from the seafloor in near-perfect condition. Its timbers still strong after more than 300 years beneath the waves. In the Black Sea, where oxygen barely reaches the depths, ancient Greek ships have been found with masts, ropes, and even cargo preserved. These underwater vaults hold history in suspension, freezing it in time. To peer into a wreck like this is to look directly into another age, as if centuries have collapsed and the ocean has quietly kept its secrets until we were ready to discover them. Sunken cities still rest beneath the waves. Not only ships, but entire cities lie beneath the ocean's surface. Off the coast of Egypt, the ancient city of Thonis Heracleion once thrived as a bustling port filled with temples and markets. Over time, the shifting seabed swallowed it, leaving its stone columns and statues hidden underwater for more than 1,000 years. In Greece, the submerged ruins of Pavlopetri reveal streets and buildings from a Bronze Age town that sank around 3,000 years ago. These drowned cities show how fragile human settlements can be in the face of rising seas and shifting land. Divers who explore them describe the surreal experience of swimming through stone streets and doorways as if visiting a dreamlike version of history. The ocean does not just erase, it preserves, holding echoes of civilizations that once thrived along its shores, now resting silently in its depths. The Bermuda Triangle has sparked centuries of mystery. Between Florida, Bermuda, and Puerto Rico lies a region of ocean, infamous in legend, the Bermuda Triangle. For centuries, sailors and pilots have told stories of ships and aircraft that vanished mysteriously within its boundaries. Some tales speak of compasses spinning wildly, of sudden storms, or of vessels disappearing without a trace. While many of these stories can be explained by natural phenomena, unpredictable weather, strong currents, or human error, the mystery lingers in the public imagination. The Bermuda Triangle has become a symbol of the unknown, a reminder that the ocean still holds secrets beyond our understanding. Whether it is simply a region of dangerous waters or something more mysterious, it continues to capture our curiosity. To gaze out across its blue expanse is to wonder what really lies beyond the horizon, hidden in the restless sea. Deep currents move water around the globe for 1,000 years. Beneath the surface of the ocean flows a hidden river, a system of deep currents that circle the planet. This global circulation is sometimes called the ocean conveyor belt. It is powered by differences in temperature and salinity, with cold, dense water sinking at the poles and slowly moving across the ocean floor. A single parcel of water may take 1,000 years to complete the journey, traveling from the Atlantic to the Pacific and back again. Along the way, it carries nutrients, heat, and carbon, linking every part of the ocean into one vast system. These currents are invisible, slow, and steady, yet they shape the climate of continents and sustain life across the seas. To imagine a single drop of water drifting for centuries through the world's oceans is to feel the planet's heartbeat pulsing softly through the deep. The ocean's tides are pulled by the moon. Twice a day, the sea rises and falls in a rhythm as old as time. These tides are caused by the pull of the moon's gravity, which tugs on Earth's oceans, drawing the water into a bulge that moves as the planet rotates. The sun also plays a role, sometimes strengthening the tides, sometimes softening them. This dance shapes coastlines, nourishes tidal marshes, and guides the lives of countless creatures. Crabs, clams, and shorebirds time their movements with the ebb and flow of the water. For humans, tides have guided sailors for thousands of years, determining when ships could leave harbour or cross shallow passages. Standing on a beach as the water draws back and then returns, you are witnessing the invisible touch of the moon itself, pulling gently on our world, a silent reminder of our connection to the cosmos. King tides can swallow entire coastlines. Most tides rise and fall predictably, but a few times each year, something remarkable happens. When the sun, moon, and earth align just right, their combined pull creates what are called king tides, the highest tides of the year. These surges can raise sea levels several feet higher than normal, flooding coastlines, covering roads, and swallowing entire beaches. To those who live near the shore, a king tide can be a powerful reminder of the ocean's reach, showing what higher sea levels might look like in the future as the climate changes. Photographers often gather to capture the spectacle of waves lapping at city streets or rising over seawalls. To watch a king tide roll in is to see the ocean claim its space, reminding us that the boundary between land and sea is never fixed but always shifting with the pull of the moon. Tsunamis can travel across entire oceans at jet speed. When a massive earthquake or landslide displaces a vast amount of water, the result is a tsunami, a wave that moves not just across a beach, but across entire oceans. Unlike ordinary waves which are caused by wind, tsunamis are driven by the movement of water itself. They can race across the sea at speeds of 500 miles per hour, as fast as a jet airplane. In the open ocean, they may appear small, only a few feet high, but as they approach shallow water, they grow into towering walls. A tsunami that begins in the Pacific can reach the shores of another continent in less than a day. Scientists use sensors and satellites to track them, but their power remains humbling. Each tsunami is a reminder that the ocean is not just a vast, quiet expanse. It is also a restless force. Storm surges can raise the sea higher than a house. When powerful storms sweep across the ocean, the winds and low pressure can push the sea itself onto the land. This is a storm surge, a massive rise in sea level that can lift the water higher than the roof of a house. Unlike a regular tide, it comes suddenly, often alongside crashing waves and heavy rain. During hurricanes, storm surges can be the most destructive force, flooding entire towns, toppling seawalls, and reshaping coastlines overnight. To those who live near the shore, the ocean's calm surface can transform into an unstoppable flood in a matter of hours. And yet, in the long view of Earth's history, such surges are part of the natural cycle of reshaping land and sea. Each surge is a reminder that the boundary we draw between ocean and shore is temporary, always shifting under the power of water. The deep holds more living mass than any other place on Earth. It may seem hard to believe, but the deep ocean is home to the largest concentration of life by biomass on the planet. Though individual animals may be small or rarely seen, their sheer numbers are staggering. Tiny creatures like copepods, krill, and jellyfish form thick clouds that stretch for miles. Enormous schools of lanternfish, estimated in the trillions, migrate up and down each day in the planet's greatest hidden journey. These creatures feed larger predators, recycle nutrients, and form the foundation of marine food webs. Together, they outweigh the total mass of all land animals combined. The deep is not barren. It's busy, intricate, and absolutely full. But because so much of that life is out of sight, we've only begun to measure it. Beneath the silence, the deep ocean is pulsing with life, more than we ever imagined. Even in the dark, life in the deep is incredibly diverse. At first glance, the deep ocean might seem like a lonely place, silent, vast, and sparsely inhabited. But that impression fades the deeper we look. In truth, the deep sea may be one of the most biodiverse habitats on Earth. Every expedition into the abyss reveals new species, glowing fish, feathery worms, jelly-like mollusks, delicate crustaceans. Many are found nowhere else. Some live in the mud, others cling to vents or coral, and still more drift freely in the water. Even within a single square meter of seafloor, scientists have counted hundreds of distinct organisms, and most of them are tiny, almost invisible to the eye. The deep rewards specialization, and creatures here have evolved in strange, isolated ways. In total darkness, diversity doesn't fade, it flourishes. Life in the deep isn't rare, it's just quiet, hidden, and exquisitely tuned to the silence. Some ocean creatures can live for over 200 years. down in the cold, dark waters of the deep, time seems to stretch. Many animals here grow slowly, age gradually, and live far longer than their surface-dwelling relatives. Some species of deep-sea clams and tube worms are known to live for more than 2 centuries. Others, like certain cold-water corals, can survive for over 4,000 years, quietly building reefs that outlast civilizations. These extreme lifespans are possible because of low temperatures, slow metabolisms, and minimal environmental stress. With fewer predators, less competition, and little need to rush, deep-sea creatures often take their time, growing patiently across decades, sometimes centuries. To us, it's nearly unimaginable. But in the deep, longevity is a way of life. Each ancient clam or coral is a living archive, a survivor of 1,000 storms, a witness to ages we've already forgotten. The Greenland shark may be 500 years old. The Greenland shark is one of the ocean's most mysterious giants, a slow-moving predator that drifts through the icy depths of the North Atlantic. For years, its age was unknown. Then in 2016, researchers made a startling discovery. Using radiocarbon dating of proteins in the shark's eye lenses, they estimated one individual to be nearly 400 years old, possibly more. Some may live to 500. That would make the Greenland shark the longest living vertebrate on Earth. These sharks grow slowly, just a few centimeters per year, and don't even reach maturity until they're around a century old. They swim in deep, frigid waters, where time moves differently, where cold and pressure stretch life across the centuries. No one has ever seen one give birth. No one knows exactly how old they can get. In the deep, age isn't counted in years, but in quiet endurance. Some waves carry the energy of nuclear bombs. It can be hard to grasp the energy contained in moving water. A single large wave driven by a powerful storm or earthquake can release as much energy as a small nuclear explosion. Imagine a wall of water rushing across the sea, with the force to lift ships, erase coastlines, and reshape landscapes. Tsunamis are the clearest examples. But even rogue waves and storm-driven swells can carry extraordinary power. Scientists studying these waves measure them not just in height, but in the energy they release, enough to dwarf anything we build. Yet, unlike the violence of human weapons, the ocean's power is not meant to destroy. It is simply part of its eternal rhythm, a natural force expressing itself in motion. To feel the ground tremble beneath the crash of such a wave is to understand how small we are beside the sea. The Pacific Ocean is larger than all continents combined. The Pacific Ocean is so vast it defies imagination. Stretching from Asia to the Americas, it covers more than 60 million square miles. To put that in perspective, the Pacific is larger than all of Earth's continents combined. Within its waters are countless islands, deep trenches, and entire ecosystems that thrive in silence and mystery. If you were to sail across its widest point, it would take weeks, even at modern speeds. For centuries, this immense ocean separated civilizations, making its islands remote worlds of their own. Even today, much of it remains unexplored. When astronauts look back at Earth, the Pacific dominates the view, a shimmering canvas of blue stretching almost unbroken across the planet. It is not just an ocean, it is a world unto itself, a reminder that water, not land, is the true ruler of Earth's surface. The Atlantic was born from a rifting supercontinent. Long ago, Earth's continents were joined together in a single landmass known as Pangaea. Over time, immense forces beneath the Earth tore this supercontinent apart, opening a crack that widened into the Atlantic Ocean. The process is still happening today. Along the mid-Atlantic ridge, new seafloor is constantly being created as molten rock wells up and pushes the continents farther apart. The Atlantic grows a few inches wider every year, slowly reshaping the map of our world. This vast ocean, which now carries ships and storms between Europe, Africa, and the Americas, was once a narrow rift. To imagine the Atlantic's birth is to imagine continents drifting like rafts, splitting and shifting across millions of years. The ocean we know today is young in geological terms, still expanding, still stretching, a reminder that even oceans are temporary in Earth's endless story. The Indian Ocean has its own monsoon circulation. The Indian Ocean is unique among Earth's great seas. Unlike the Pacific or Atlantic, which are largely shaped by steady currents, the Indian Ocean breathes with the rhythm of the monsoons. Each year, the winds reverse direction. In summer, warm air over the land pulls moist ocean winds inland, bringing heavy rains that sustain billions of people. In winter, the winds reverse, blowing dry air out to sea. This seasonal heartbeat has shaped civilizations for thousands of years, guiding trade, agriculture, and culture across South Asia, Africa, and the Middle East. Traders once timed their voyages to the monsoon winds, crossing vast distances when the currents were favorable. Even today, the monsoon is vital, bringing life-giving rains but also fierce storms. The Indian Ocean reminds us that the sea is not just water. It is a force that shapes human history itself. The Mariana Trench is Earth's deepest scar. The Mariana Trench, located in the western Pacific, holds the record for the deepest part of Earth's oceans and of the planet's crust. It plunges nearly 11,000 meters below sea level at its lowest point, known as the Challenger Deep. That's deeper than Mount Everest is tall. The trench is not a crack or a canyon, but a vast curving depression formed by immense geological forces. It's the result of one tectonic plate sliding beneath another in a process called subduction. The result is a kind of scar, a slow grinding wound in the Earth's surface that has been growing for tens of millions of years. Down there, the water is near freezing, the pressure is crushing, and light never reaches. Yet, even in this most extreme environment, life finds a way. The Mariana Trench reminds us how deep the Earth truly goes, and how far mystery can stretch. Trenches form where continents sink into the mantle. Oceanic trenches are some of the deepest and most dramatic features on the planet, and they are created by one of the most powerful processes in geology, subduction. Along certain boundaries, tectonic plates collide, and the denser oceanic crust is forced downward beneath lighter continental crust. As it sinks, it drags material deep into Earth's mantle, forming a deep trench at the boundary line. These trenches can be thousands of kilometers long and several kilometers deep. They are zones of earthquakes, volcanoes, and intense pressure. But they are also ancient, marking the slow recycling of Earth's surface over tens of millions of years. The Pacific Ocean is ringed by these deep scars, forming what's known as the Ring of Fire. From above, they are invisible, but far below, they are the grinding edges of continents, places where the crust folds, cracks, and disappears into the deep. Even the deepest trenches host strange living creatures. For years, scientists believed that nothing could survive in the crushing darkness of the ocean's deepest trenches. But they were wrong. With the help of deep-diving submersibles and robotic landers, we've discovered that even the Challenger Deep, nearly 11 kilometers down, is home to life. Amphipods scuttle through the mud, microbes live in the sediments, and strange translucent fish with fragile fins and ghostly bodies drift slowly near the bottom. These creatures survive in freezing temperatures with no sunlight and under pressures over 1,000 times that of the surface. They've adapted in ways we're still trying to understand, with flexible membranes, pressure-resistant enzymes, and unique metabolic tricks. Even at the very limits of the biosphere, life refuses to yield. The deepest trenches are not lifeless voids, they are hidden worlds, fragile, quiet, and still very much alive. Some fish thrive in waters with almost no oxygen. In many parts of the deep ocean, oxygen levels are so low they would suffocate most known animals. These oxygen minimum zones exist at depths between 200 and 1,000 mil, places where the water is too far from the surface to be refreshed by the wind, and too deep for photosynthesis. But life still finds a way. Some species of fish, like the slender fangtooth or certain types of lanternfish, have evolved to survive with barely any oxygen at all. They slow their metabolisms, reduce muscle activity, and rely on specialized proteins that help them extract the tiniest traces of oxygen from the water. Others may use gills with massive surface areas or shift their behavior to avoid the worst conditions. These fish don't just survive where others would die, they thrive. In the quiet, oxygen-starved deep, resilience is everything. Submarine canyons funnel sediment to the deep. Along the edges of continents, the seafloor is carved into deep valleys known as submarine canyons. These canyons act like underwater highways, funneling sediments, nutrients, and even organic matter from the coast down into the deep sea. Some are carved by ancient rivers, others by underwater landslides or the slow pull of currents. Monterey Canyon, for example, cuts deep into the seafloor of California's coast, rivaling the Grand Canyon in scale. These hidden valleys are vital to marine life. Nutrients carried down their slopes feed ecosystems in the depths, sustaining creatures that might otherwise starve in the dark. Submarine canyons also act as corridors for marine animals, guiding migrations and sheltering life. Though hidden beneath the waves, they are as dramatic and important as any canyon on land. They remind us that Earth's greatest landscapes often lie where we cannot see them. The Mid-Atlantic Ridge is the longest mountain chain on Earth. Hidden beneath the ocean lies the longest mountain range in the world, the Mid-Atlantic Ridge. Stretching for more than 40,000 kilometers, it winds like a seam down the center of the Atlantic Ocean, from the Arctic all the way to the southern tip of Africa. Unlike the dramatic peaks of the Himalayas, this range rises from the seafloor, its summits mostly buried beneath miles of water. It is formed where tectonic plates pull apart, allowing molten rock to rise and create new crust. In some places, the ridge breaks the surface, forming islands like Iceland, where volcanoes still shape the land. From above, it is invisible, but on maps, it appears as a jagged scar across the ocean floor. This hidden mountain range is a reminder that Earth's greatest features often lie in places we cannot see, vast, silent, and mysterious. Volcanoes rise thousands of meters from the ocean floor. When we imagine volcanoes, we picture fiery peaks rising above the land. But many of Earth's tallest volcanoes lie beneath the ocean, unseen. Seamounts and submarine volcanoes can rise thousands of meters from the seafloor, forming immense mountains that never break the surface. Some are still active, sending plumes of ash and hot water into the sea, reshaping the landscape in silence. In fact, the tallest mountain on Earth isn't Everest, it's Mauna Kea in Hawaii. From its base on the seafloor to its summit above the waves, it stands taller than any other mountain on the planet. These underwater volcanoes are more than just geological wonders. They create new habitats for marine life, release nutrients into the sea, and shape the islands and coastlines we know. Beneath the waves, the Earth is still building itself, one fiery eruption at a time. Entire islands are born from submarine eruptions. Sometimes the ocean itself gives birth to new land. When underwater volcanoes erupt with enough force, they can build mountains that rise all the way to the surface, breaking through as brand new islands. In recent decades, small volcanic islands have appeared suddenly in places like Iceland and Japan, steaming and smoking as they emerge from the sea. Some last only a short time, quickly eroded by waves. Others stabilize, becoming permanent additions to the map. The Hawaiian Islands themselves were born this way, rising from the ocean over millions of years of volcanic activity. To witness such an event is to see creation in real time, the Earth reshaping itself before our eyes. From the depths of the sea, new worlds are born, a reminder that our planet is never finished, always changing, always alive with hidden fire. Now we know they have tentacles longer than a bus. A fully grown giant squid can reach lengths of up to 13 meters, more than the length of a city bus. Most of that size comes from two incredibly long feeding tentacles, which are tipped with suckers lined with tiny serrated rings. These tentacles can shoot out to snatch prey with astonishing speed, drawing fish and other squid back toward a hooked beak hidden at the center of the arms. The giant squid's body is soft and boneless, allowing it to survive at extreme depths and squeeze through narrow gaps. But its size and power are undeniable, especially when you realize that it may not even be the largest squid in the sea. The colossal squid, its close cousin, might be even heavier. Deep in the darkness, unseen battles between giants could still be taking place. Tentacle against tooth, myth against mystery. The colossal squid has eyes the size of dinner plates. Of all the creatures that inhabit the deep ocean, none has eyes quite like the colossal squid. Each eye can reach 25 centimeters in diameter, about the size of a large dinner plate. They are the largest eyes known in the animal kingdom, evolved to gather the faintest glimmers of light in the abyss. With such eyes, the squid can detect distant bioluminescent flashes, the ghostly flicker of prey, or the approach of a predator. These massive creatures are rarely seen, but when they are, they leave a powerful impression. One specimen captured near Antarctica had sharp, swiveling hooks on its arms and weighed over 500 kilograms. The colossal squid is bulkier and more powerfully built than its giant cousin, and it may still be growing. In the frozen dark of the Southern Ocean, this nearly mythic beast drifts, enormous and unseen. Some deep creatures keep growing their entire lives. On land, most animals stop growing once they reach adulthood. In the deep ocean, it's not always so simple. Many species, including some fish, crustaceans, and cephalopods, continue growing throughout their lives, slowly adding mass and size over the years. This phenomenon, known as indeterminate growth, may help these creatures adapt to the harsh conditions of the deep, low temperatures, scarce food, and immense pressure. It also means that given enough time, some deep-sea animals can reach enormous sizes. Slow metabolism and long lifespans allow for gradual, almost glacial growth. In this still, cold world, nothing needs to hurry. Over decades or even centuries, a small creature might become a giant, and we may have only seen the younger ones. Somewhere in the darkness, the elders of the deep may still be growing, unseen and unmeasured, older than memory. The frilled shark looks like a fossil come to life. Sometimes called a living fossil, the frilled shark is one of the most ancient-looking creatures in the ocean. It has a long eel-like body, a wide mouth full of needle-like teeth, and gill slits that form frills along its throat. It rarely ventures near the surface, spending most of its life in the cold, dark depths between 500 and 1,000 below. Its lineage dates back over 80 million years, and its body has changed very little since then. It moves in slow serpentine motions, striking quickly when prey comes near. Few people have ever seen one alive. Most encounters come from deep trawling nets or remote cameras. But every glimpse reminds us that the ocean holds creatures shaped by ancient worlds, animals that seem to have drifted forward through time, carrying echoes of the distant past. Others build skeletons that last for millennia. Corals may seem delicate, but their skeletons can endure for thousands of years. As each tiny polyp builds its limestone home, it leaves behind a structure that remains long after it dies. Over centuries, these skeletons accumulate into massive reefs, some of which have been growing for more than 8,000 years. The Great Barrier Reef, stretching across Australia's coast, is so vast that it can be seen from space. Even when corals die, their skeletons provide a foundation for new life to grow, layer upon layer, like the rings of a tree. In this way, reefs are both living and ancient, constantly renewing themselves, yet preserving the memory of generations long gone. They remind us that even the smallest creatures, working together, can create structures that endure longer than cities, longer than civilizations, longer than the memory of humankind itself. Coral polyps can clone themselves to expand the reef. Coral reefs are built by polyps so small you could miss them with the naked eye. Yet these creatures have an extraordinary ability. They can clone themselves. When a polyp divides, it creates an identical copy, which settles nearby and begins building its own skeleton. Over time, these clones form colonies, expanding outward into elaborate structures. It's like a living organism that builds its own home brick by microscopic brick. This ability allows reefs to grow steadily for thousands of years, spreading across vast stretches of ocean floor. Each new polyp is both a separate creature and part of the whole, connected to its neighbours, sharing food and protection. The result is one of the most intricate ecosystems on Earth. Coral cloning is a quiet, patient process, But over centuries it builds something breathtaking, entire living continents beneath the waves. Reef ecosystems are among the most diverse on Earth. Step into a coral reef and you are entering one of the most diverse ecosystems on the planet. Thousands of species live together in a single reef. Fish of every colour, tiny shrimp cleaning larger creatures, sea turtles grazing on seagrass, and sharks gliding silently above. The reef provides food, shelter, and breeding grounds for about a quarter of all marine species, despite covering only a tiny fraction of the ocean floor. This concentration of life rivals even the richest rainforests. The interactions within a reef are delicate and complex, with every creature depending on others for balance. A small change, a shift in temperature, a drop in water quality can ripple outward, affecting the entire system. To float above the reef is to watch life in its most dazzling and intricate form, a living mosaic of colour and motion woven by the sea itself. The Great Barrier Reef is visible from space. From the window of a spacecraft orbiting Earth, the Great Barrier Reef appears as a ribbon of turquoise and emerald stretching along Australia's northeast coast. At more than 1,400 miles long, it is the largest living structure on Earth. So vast that astronauts can see it with the naked eye. What they are really looking at is billions of tiny coral polyps, each building a limestone home, generation after generation, until they form an underwater metropolis. The reef is alive with colour and motion, schools of fish glinting like silver sparks, sea turtles gliding in silence, and manta rays sweeping gracefully overhead. To know that something so alive, so delicate, can be seen from orbit is astonishing. From the emptiness of space, Earth shines as a blue planet, and the reef glimmers as a jewel upon its surface. Sound travels faster in the deep than in the air. In the ocean, sound behaves very differently than it does in the air. Water is denser and more elastic, which means sound waves move through it much faster, about 4 times faster. In fact, the deeper you go, the faster the sound travels. At the surface, sound might move at around 500 mph, but in the crushing pressures of the deep, it can be even faster. This speed allows whales to call across vast distances, sometimes hundreds of kilometers, and it's not just faster. Sound also travels farther underwater than light or smell. That's why so many deep-sea creatures rely on sound to communicate, navigate, and hunt. In a world without light, hearing becomes one of the only ways to sense the environment. The ocean is often described as silent, but in truth, it's full of sound. We just haven't always known how to listen. The ocean has a hidden layer that traps sound like a whispering cave. Deep beneath the surface lies a strange acoustic phenomenon called the SOF channel, short for sound fixing and ranging. It's a horizontal layer of water where the speed of sound is at its lowest due to a perfect balance between temperature and pressure. Sound waves entering this layer don't scatter in all directions. They get bent back inward, trapped and funneled horizontally across vast distances. A single low-frequency sound can travel for thousands of kilometers inside the SOF channel, barely losing energy. Submarines use it, so do whales, and in the 1960s, scientists even placed underwater microphones here to monitor for distant nuclear tests. It's like a natural whispering gallery that encircles the globe, a place where voices can travel far beyond the horizon. In the deep sea, this hidden sound tunnel connects worlds that are otherwise lost in darkness and silence. We've recorded bizarre noises in the deep we can't explain. Ever since humans began listening to the ocean, with underwater microphones called hydrophones, we've picked up sounds that defy explanation. Some are low rumbles, others are short bursts or eerie moans. Many don't match the patterns of any known marine creature, seismic event, or man-made noise. Scientists have catalogued these unexplained sounds, often giving them whimsical names like upsweep, slowdown, and Julia. Some are seasonal, some only happen once. Their origins remain mysterious. Are they caused by shifting icebergs, deep undersea quakes, massive animals we've never seen? We don't yet know. These sounds remind us how much of the ocean remains uncharted, not just visually, but acoustically. The deep sea isn't silent. It speaks in voices we can record, but not always understand. Listening to these unknown echoes is like overhearing a conversation in a language we haven't learned yet. Some fish use choral sounds to find their way home. When young fish are born, many drift for weeks or months in the open ocean, carried by currents far from home. But when it's time to settle, how do they find their way back to the reef? The answer is sound. Reefs are anything but silent. They crackle with the noise of snapping shrimp, fish calls, and the faint hum of life. Baby fish can hear these sounds from miles away, and they use them as a kind of underwater beacon, guiding them home. Scientists discovered that fish placed in speakers broadcasting reef sounds were drawn toward them, navigating through the dark water with their ears. This means reefs are not only colourful to the eye, but also rich in hidden soundscapes that shape the lives of creatures. The ocean speaks in ways we cannot hear, and its children listen carefully. Tides expose vast mudflats full of hidden life. When the tides retreat from coastal shores, they reveal wide stretches of glistening mudflats. At first glance, these flats look empty, but they are alive with hidden life. Beneath the wet sand, clams and worms burrow, waiting for the water to return. Crabs scuttle sideways across the surface, leaving tiny tracks that disappear with the next wave. Birds flock to the exposed flats, probing the mud for food. Entire ecosystems depend on this daily rhythm, the sea pulling back to reveal its secrets before sweeping in again. For humans walking across these landscapes, the ground may feel soft and endless, dotted with shells and rippling patterns. Mudflats are reminders that even in the simplest, quietest places, life is abundant. They are the ocean's secret gardens, revealed only for a few hours at a time, then hidden again beneath the returning tide. Some crabs can climb trees. When we think of crabs, we imagine them scuttling along the sand or hiding in rocky tide pools. But in tropical islands across the Indian and Pacific Oceans, some crabs have taken to the trees. Coconut crabs, the largest land-dwelling arthropods in the world, can climb towering palms with ease, using their powerful legs to grip the bark. They climb to snatch coconuts, which they can crack open with claws strong enough to snap bones. These giants can weigh more than 9 leopards and stretch nearly 3 feet across. Despite their size, they are expert climbers, moving silently among the leaves. Smaller species like mangrove crabs also climb trees to feed on leaves and escape predators. To see a crab clinging to a branch high above the water is surreal, a creature of the sea returning to the air, exploring yet another world. Sea cucumbers clean the ocean floor. On the sea floor, countless creatures sift through sand and mud, recycling nutrients in ways that keep the ocean alive. Among the most important are sea cucumbers, soft tube-shaped animals that creep slowly across the bottom. As they feed, they swallow sand and organic matter, digest what they need, and expel the rest, leaving behind clean sediment. In this way, they act like the earthworms of the sea, turning over the seabed and keeping ecosystems healthy. In some regions, entire stretches of the ocean floor are covered with sea cucumbers, quietly working as cleaners. Despite their simple appearance, they play a vital role in keeping marine life thriving. Without them, the seafloor could become clogged with waste, suffocating the creatures that live there. Sea cucumbers remind us that even the humblest forms of life can be essential, silent caretakers of the ocean's endless floor. Some deep-sea creatures glow like living lanterns. In the blackness of the deep ocean, light becomes a precious resource, and many creatures have evolved to produce their own. This phenomenon is called bioluminescence, and it is astonishingly widespread in the deep sea. Fish, squid, jellyfish, plankton, all capable of emitting light in soft blues, greens, and even rare reds. They do it using chemical reactions inside specialized cells or organs, creating eerie glows that hover in the dark. Some use it to lure prey, others to attract mates. Some flash patterns to confuse predators or even vanish by cancelling out their own shadows. Bioluminescence is more than beautiful. It's a language of survival. For the creatures that live beyond sunlight, light is both camouflage and signal, weapon and shield. It may be the only thing more common than darkness in the deep, and it turns the midnight ocean into a flickering galaxy of life. Bioluminescence may be the most common light on Earth. Imagine a world where most light isn't from the sun, but from living things in the deep ocean. That's exactly what happens, because the vast majority of Earth's living space lies in the dark deep sea. The light created by bioluminescent creatures may actually outshine all other natural light sources on the planet. Tiny plankton blink and shimmer as they drift. Fish glow from within. Jellyfish pulse with faint halos. The light is soft, often blue or green, and it travels farther underwater than other colours. This natural glow isn't just beautiful, it's vital. It helps creatures find food, evade predators, and even coordinate movements in the dark. Some fish can flash like lightning, others can keep glowing for minutes on end. On land, we think of light as coming from the sky, but beneath the waves, it comes from the life that hides in the dark. The vampire squid drifts through pitch-black waters like a ghost. Despite its fearsome name, the vampire squid is a gentle creature. Slow-moving, delicate, and unlike anything else in the sea, it lives in the oxygen-starved depths of the mesopelagic zone, where few predators dare to follow. Its body is soft and gelatinous, with a cloak-like membrane that stretches between its arms. Inside, it has glowing blue eyes, some of the largest eyes proportionally of any animal on Earth, perfectly tuned to pick up the faintest trace of light. When threatened, it doesn't squirt ink. Instead, it releases a cloud of glowing mucus filled with bioluminescent orbs. These floating sparks confuse predators, buying the squid time to vanish into the dark. It doesn't hunt for fish. Instead, it collects drifting organic particles, marine snow with long filaments, like catching stardust. The vampire squid is not a monster, but a marvel, a living ghost in a world without light. Giant tube worms thrive in water hotter than boiling, clustered around hydrothermal vents, where superheated water spills into the freezing deep. Live some of the most unusual animals on Earth, giant tube worms. They can grow over 2 meters long and live in tubes made of hardened protein, forming thick red and white forests on the ocean floor. They have no mouths, no digestive tracts. Instead, these worms host colonies of chemosynthetic bacteria inside their bodies. The bacteria feed on toxic chemicals from the vent, like hydrogen sulfide, and convert them into energy. In return, the worms provide a safe home. This symbiosis allows them to survive in scalding temperatures, crushing pressure, and total darkness. It's an ecosystem built entirely on chemistry, with no need for sunlight. The discovery of tube worms stunned scientists and showed that life could thrive in places previously thought uninhabitable. They may be Earth's most alien creatures, living in a world shaped by fire. Some fish can see colours humans never will. In the dark depths of the ocean, colour might seem useless. After all, most visible light never reaches beyond a few hundred meters. But some deep-sea fish have evolved eyes that can detect parts of the light spectrum we can't see, including near-infrared and certain shades of red or ultraviolet. These special adaptations allow them to spot prey that tries to hide using camouflage, or even communicate using subtle flashes invisible to other predators. The brown snout spookfish, for example, has a mirror-like structure in its eye that helps it detect faint glimmers of light from below. Other species have multiple visual pigments tuned to different wavelengths, giving them an almost alien kind of vision. Where we would see only blackness, these fish can detect flickers and shadows, hints of movement, signs of life. In the ocean's eternal night, their eyes become their secret advantage. Cuttlefish can disappear in a flash of camouflage. Cuttlefish are masters of disguise. With a single thought, their skin can shift from pale sand-coloured patterns to dazzling stripes, spots, or swirls. Special cells called chromatophores expand and contract, revealing or hiding pigments instantly. This allows them to vanish against their surroundings, blending so perfectly that predators pass by without noticing. But camouflage is only part of their magic. Cuttlefish can also produce rippling waves of colour across their bodies, mesmerising prey until it drifts close enough to catch. To human eyes, it looks like living artwork, a canvas that changes with every pulse of the animal's skin. What makes this even more astonishing is that cuttlefish are colorblind. They create patterns and colors they cannot even see, guided by instincts written deep in their biology. In the quiet ocean, they are artists without eyes for their own masterpieces. Squid can communicate using pulses of color. While some creatures rely on sound to speak, many squid use light and color instead. Their skin is covered in specialized cells that can flash, shimmer, or darken in patterns. By pulsing stripes or waves of color, squid communicate with one another, signaling danger, confusing predators, or coordinating hunts. Some researchers believe they even use these displays as a kind of language, sending messages in rapid, silent flashes. To watch a school of squid in the deep sea is to see a conversation in light, a living code written across their shifting bodies in an environment where sound carries strangely and visibility is limited. This luminous communication is both practical and beautiful. It suggests that intelligence can take many forms, not just in words and voices, but in the flickering glow of colors across the skin of creatures beneath the waves. Some fish can produce electricity. Imagine swimming through the ocean and encountering a creature that glows with its own power, not just with light, but with electricity. Electric fish, like the electric eel, can generate powerful shocks strong enough to stun prey or deter predators. These shocks come from specialized cells called electrocytes, which store and release electricity like tiny batteries. Some fish use weaker pulses to communicate, sending electric signals to one another in the dark. Others unleash jolts powerful enough to knock a human unconscious. For them, electricity is not just a phenomenon of machines, but a natural part of their bodies, as ordinary as muscle or bone. The ocean is full of such surprises, creatures that have taken the very forces of physics and made them their own. It is a reminder that life can learn to wield even the raw power of lightning. Others can leap clear out of the water. The ocean's creatures are not always confined to the sea. Many fish have evolved the ability to leap clear of the water, launching themselves into the air with sudden bursts of speed. Flying fish are the most dramatic, using their wing-like fins to glide above the waves for hundreds of feet at a time, skimming the surface like silver arrows. They do this to escape predators, trading the dangers of the deep for the brief freedom of the sky. Other fish leap to catch insects, or even to migrate upstream, as salmon do when they hurl themselves against waterfalls in their journey to spawn. Each leap is a reminder that the boundary between water and air is thin, and that life is never limited by a single world. In these fleeting, sparkling arcs above the waves, the ocean touches the sky. Entire mountain ranges are hidden beneath the waves. Beneath the ocean surface lies one of the longest and least visible mountain ranges on Earth, the mid-ocean ridge. It stretches more than 60,000 kilometers around the globe, snaking through every ocean basin. These underwater mountains rise from deep rifts where Earth's tectonic plates pull apart, allowing molten rock to well up and cool into new crust. In places, the ridge rises high enough to form islands like Iceland, but most of it remains hidden beneath miles of water. Towering peaks, deep valleys, and volcanic vents make this range one of the most geologically active places on the planet. And yet, we've barely mapped it. These submerged mountains influence ocean currents, house entire ecosystems, and shape the planet's crust, all without ever breaking the surface. In the deep ocean, even mountains can go unnoticed, silent and immense beneath the rolling waves. The anglerfish hunts with a glowing orb on its head. One of the most haunting predators in the deep is the anglerfish, a creature with razor teeth, a wide hollow jaw, and a glowing lure that dangles from its forehead. That glowing orb is a modified spine tipped with bioluminescent bacteria. In the endless blackness of the deep sea, it acts like a beacon, attracting small fish or squid that swim toward what looks like food, only to be swallowed whole. The anglerfish doesn't chase prey. It waits in stillness, jaws open, light swaying softly, and when something draws near, it strikes. Females can grow much larger than males and carry the lure. In some species, males fuse permanently with females, becoming little more than living sperm banks. It's a strange, haunting existence. But in a world without sunlight, a single point of light flickering in the dark can mean the difference between survival and starvation. Superheated vents create alien worlds at the bottom of the sea, far beneath the waves where tectonic plates pull apart and Earth's crust thins. Cracks open in the seafloor. From these fissures, superheated water pours out, dark, mineral-rich and scalding hot. These are hydrothermal vents, and they can reach temperatures over 400 degrees C. Yet, even here, in conditions that would destroy most known life, ecosystems flourish. The vents create towering chimneys of black smoke built from dissolved minerals. Around them, life gathers in dense, thriving colonies, tube worms, giant clams, swarming shrimp. It feels more like science fiction than Earth, like some deep alien planet lit from below. These vents don't rely on sunlight, but on chemistry. And they remind us that life doesn't need light, warmth, or air, only energy wherever it's found. In the deepest darkness, where the Earth itself breathes, the ocean builds glowing cities of heat and stone. Most of Earth's ocean is wrapped in eternal darkness. If you were to dive beneath the ocean's surface, the light would begin to fade surprisingly quickly. By about 200 meters down, not even a tenth of the way through the ocean's average depth, sunlight disappears almost entirely. Beyond this lies a realm of twilight, then total blackness. The deep ocean is so vast, so profoundly dark, that most of the light on Earth never reaches it. This darkness is not a temporary shadow, but a permanent feature, a kind of planetary night that stretches across millions of square kilometers. And yet, despite this absence of light, the deep is far from lifeless. Creatures here have evolved to see without seeing, to glow in the dark, and to thrive in a world untouched by day. It is a darkness not of emptiness, but of mystery, one that stretches further than the eye could ever follow. As this journey through the ocean comes to rest, the vastness beneath the surface can be left behind, still moving, still unfolding, far beyond awareness. The deep continues its slow rhythms, carrying life, heat, and motion through darkness and time. Creatures drift, currents turn, and hidden landscapes remain where they have always been, quiet and unchanged by attention. What has been explored here is only a small glimpse of a world that never truly sleeps. The ocean will keep shaping the planet, sustaining life, and holding mysteries long after this moment fades. Its depths remind us that not everything needs to be seen to matter, and not every question needs an answer right away. If this calm exploration brought a sense of wonder or rest, you are always welcome to return. These quiet moments exist to slow the mind and let curiosity soften into peace. But for now, allow your mind to settle. Let the body grow still, and let the wonders of the ocean carry you to sleep. Good night.